Hi and welcome to the first section of our video course, where we'll create our first app with Ionic 2. In this section we'll get introduced to the Ionic 2 framework with instructions on how to set up the development environment and quickly create and run our first app. We'll cover the topics: setting up a development environment, creating a Hello World app via the CLI, creating a Hello World app via Ionic Creator, viewing the app using your web browser, viewing the app using the Ionic CLI, viewing the app using Xcode for iOS, viewing the app using Genymotion for Android, viewing the app using Ionic View. Now we move on to the first video of this section that deals with setting up a development environment. In this video we're going to take a look at how to set up an environment to build comprehensive apps by installing Sublime Text Editor, Visual Studio Code Editor and Sublime packages. Before you create your first app, your environment must have the required components ready. These components ensure a smooth process of development, build and test. The default Ionic project folder is based on Cordovas. Therefore, you need the Ionic CLI to automatically add the correct platform, that is iOS, Android or Windows Phone, and build the project. This will ensure all Cordova plugins are included properly. The tool has many options to run your app in the browser or simulator with live reload. We need to install Ionic and its dependencies to get started. Ionic itself is just a collection of CSS styles, Angular JS components and standard Cordova plugins. It's also a command line tool to help manage all technologies such as Cordova and Bower. The installation process will give you a command line to generate the initial code and build the app. Ionic uses npm as the installer, which is included when installing Node.js. Please be sure to install the latest version of Node.js from this site. So just click on Macintosh Installer so that our package will be downloaded here. Now we need to install Cordova, iOS-sim, that is iOS Simulator and Ionic. Let's go to the command prompt. Type this command in the terminal. You can install all three components with this single command line instead of issuing three command lines separately. The -g parameter is to install the package globally, not just in the current directory. For Linux and Mac, we may need to use the sudo command to allow system access. Run this command in the sudo. On clicking enter, let's type our Mac password. Once this is done, as you can see, it will start installing. So you can see that it's now installed. There are a few common options for integrated development environment, which are Xcode for iOS, Android Studio for Android, Microsoft Visual Studio Code, VS Code, Sublime Text, www.sublimetext.com for web development. To install Sublime Text, go to this website and click on the download option. All of these have a free license. You could code directly in Xcode or Android Studio, but those are somewhat heavy duty for web apps, especially when you need to have lots of windows open and just need something simple to code. Sublime Text is free for non-commercial developers, but you have to purchase a license if you're a commercial developer. Most front-end developers would prefer to use Sublime Text for coding HTML and JavaScript, because it's very lightweight and comes with a well-supported developer community. Sublime Text has been around for a long time and is very user-friendly. However, there are many features in Ionic 2 that make Visual Studio Code very compelling. For example, it has the look and feel of a full IDE without being bulky. You could debug JavaScript directly inside VS Code as well as getting autocomplete, for example in IntelliSense. We're going to look at how to install Sublime Text and VS Code. Let's take a look. Download Visual Studio from this site called code.visualstudio.com. Download the software from here. Once done, we need to install for our specific OS. Unzip the downloaded file and drag the .app file into the application folder and drag it to the Mac's dock. I've already installed here. Now, open Microsoft Visual Studio Code. It will look like this. Then press Command-Shift-P to open the command palette and type the shell command. Click on the Install Code command in Path command to install the script and add Visual Studio Code to your terminal .path. So, as you can see, the shell command code has been successfully installed in the path. Now restart the Visual Studio Code to take effect. Later on, you can just do .code directly from the Ionic project folder, and VS Code will automatically open that folder as a project. Let's take a look at that. Here, we'll directly go to the Ionic folder. type the command code space dot. With this, it will directly launch the Visual Studio Code. If you decide to use Sublime Text, you will need package control at this site, which is similar to a plugin manager. Since Ionic uses Sass, it's optional to install the Sass syntax highlighting package, so you can refer as highlighted. Once you've downloaded the steps here, download the package control.sublime package from here and install. Once this is done, go to the Sublime, Preferences, Package Control. Go to Package Control and Install Package. You could also just type the commands partially, that is, inst, and it will automatically select the right option. Now type Sass and the search results will show only one option for TextMate and Sublime Text. Select the item to install. There are tons of Sublime Text packages that you might want to use, such as HTML, JS Hint, JS Lint, Tag and Color Picker. You can visit this popular website for additional needs and learn more about it. In this video we set up our environment to create apps. In the next video we'll create a Hello World app via the CLI. Hi, this is a new video of the section Creating a Hello World app via the CLI. In the previous video we got to know how to set up an environment to create apps. In this video we're going to create a Hello World app using the CLI. It's quickest to start our app using the existing templates. Ionic gives you the following 3 standard out-of-the-box templates via the command line. Blank. This is a simple page with minimal JavaScript code. Tabs. These are multiple pages with roots. A root URL goes to each tab. Side menu. This is a template with a left-right menu with a center content area. Now let's see how to get started. To set up the app with a blank template from Ionic, we'll use this command. Please note that if you don't have an account in ionic.io, the command line will ask for it. You can either press yes or no to continue. It's not mandatory to have an account at this step. As you can see, it's downloading the required files. Now, if we replace blank with tabs, it will create a tab template. For that, let's type the Ionic start command. Similarly, we'll create an app with a side menu. The side menu template is the most common template, as it provides a very nice routing example with different pages in the app, Pages folder. Additional guidance for the Ionic command line interface is available on the GitHub page, as mentioned in the GitHub link here. It's now time for us to see how it works. This video will show you how to quickly start your code base and visualize the result. More details about AngularJS 2.0 and its template syntax will be discussed in the later sections of this course. However, the core components are given here. Component. AngularJS 2.0 is very modular because you could write your code in a file and use an export class to turn it into a component. If you're familiar with AngularJS 1.x, this is similar to a controller and how it binds with a DOM node. A component will have its own private and public properties and methods, that is, functions. To tell whether a class is an AngularJS component or not, you have to use the component decorator. This is a new concept in TypeScript, since you could enforce characteristics, metadata, on any class so that they behave in a certain way. Template. A template is an HTML string or a separate HTML file that tells AngularJS how to render a component. This component is very similar to any other front-end and back-end framework. However, AngularJS 2.0 has its own syntax to allow simple logic on the DOM, such as repeating rendering, *ng4, event binding, click, or custom tags, my-tag. Directive. This allows you to manipulate the DOM, since the directive is bound to a DOM object. So, *ng4 and *ngif would be examples of directives because they alter the behavior of that DOM. Service. This refers to the abstraction to manage models or collections of complex logic besides get set required. There is no service decorator as with a component, so any class could be a service. Pipe. This is mainly used to process an expression in the template and return some data, that is, rounding numbers and adding currency. For example, the expression pipe filter format. For example, amount pipe currency will return $100 if the amount variable is 100. Now, Ionic automatically creates a project folder structure that would look as follows. You'll spend most of your time in the /app folder because that's where your application components will be placed. This is very different from ionic1.x because the www folder here is actually compiled by TypeScript. If you build the app for iOS, the Ionic build command line will also create another copy at platforms iOS www, which is specifically for Cordova to point to. Another interesting change in AngularJS 2.0 is that all custom JS and CSS files are placed in the same subfolder, or in app, pages. Since AngularJS 2.0 is component-based, each component will come with HTML, CSS, and JS. If you add in more JavaScript modules, you can put them in the app folder, or a better practice is to use npm install so that it's automatically added to the node_modules folder. Ionic 2 completely got rid of grunt and bower. Everything is simplified into just package.json, where your third-party dependencies will be listed. There is no need to modify the platforms or plugins folder manually unless troubleshooting needs to be done. Otherwise, the Ionic or Cordova CLI will automate the contents inside these folders. By default, from the Ionic template, the AngularJS app name is called MyApp. You'll see something like this in app.js, which is the bootstrap file for the entire app. Here, this is the Ionic root component where the app will be loaded. This is acting as the root of your app, and all content will be injected inside the Ion syntax of index.html. Note that if you double-click on the index.html file to open it in the browser, it will show a blank page. This doesn't mean that the app isn't working. The reason for this is that the Angular component of Ionic dynamically loads all the .js files, and this behavior requires server access via the HTTP protocol. If you open a file locally, the browser automatically treats it as a file protocol, and therefore Angular will not have the ability to load additional JS modules to run the app properly. There are several methods of running the app, which will be discussed in the later videos. In this video, we created a Hello World app via the command line interface. In the next video, we'll create a Hello World app via Ionic Creator. Welcome to the video Creating a Hello World app via Ionic Creator. In the previous video, we created a sample app via the CLI. In this video, we're going to take a look at creating a Hello World app via Ionic Creator. Another way to start your app codebase is to use Ionic Creator. This is a great interface builder to accelerate your app development with drag and drop style. You can quickly take the existing components and position them to visualize how it should look in the app via a web-based interface. Most common components, such as buttons, images, and checkbox, are available. Ionic Creator allows the user to export everything as a project with all .html, .css, and .js files. You should be able to edit content in the app folder to build on top of the interface. Ionic Creator requires registration for a free account at creator.ionic.io to get started. Once done, click on My Project. Type the project name, that is My App, choose a blank template, and click on Create. Now validate to ensure that this screen is seen. The center area is our app interface. The left side gives us a list of pages. Each page is a single root. We also have access to a number of UI components that we would normally have to code by hand in an HTML file. The panel on the right shows the properties of any selected component. You're free to do whatever you need to do here by dropping components in the center screen. If you need to create a new page, you have to click on the plus sign in the Pages panel. Each page is represented as a link, which is basically a root in Angular UI router's definition. To navigate to another page, for example after clicking a button, you can just change the link property and point to that page. There is an edit button on top where we can toggle back and forth between the edit mode and preview mode. It's very useful to see how your app will look and behave. Once completed, click the Export button on the top of the navigation bar. Use the Ionic CLI tool to get the code, then download the project as a zip file and export it to native code. The best way to learn Ionic Creator is to play with it. We can add a new page and pick out any of the existing templates. This is a login page template. This is how it looks. To switch to the preview mode, where you can see the UI in a device simulator, click on the switch button in the top right to enable test. If you break something, it's very simple to start a new project. It's a great tool to use for prototyping and to get the initial template or project scaffolding. You should continue coding in your regular IDE for the rest of the app. Ionic Creator doesn't do anything for you yet. For example, if you want to access specific Cordova plugin features, you have to write the code for that separately. Also, if you want to tweak the interface outside of what is allowed within Ionic Creator, it will also require specific modifications to the .html and .css files. In this video, we created a Hello World app using Ionic Creator. In the next video, we'll view our app using the web browser. Welcome to the video viewing the app using your web browser. In the previous video, we created a Hello World app via Ionic Creator. In this video, we're going to take a look at viewing our app using web browser. In order to run the web app, you need to turn your www folder into a web server. Again, there are many methods to do this, and people tend to stick with one or two ways to keep things simple. A few other options are unreliable, such as Sublime Text's Live Watch package or Static Page Generator, for example the Jekyll and Middleman apps. They're slow to detect changes and may freeze your IDE, so those won't be mentioned here. The recommended method is to use the Ionic Serve command line. It basically launches an HTTP server so that you can open your app in a desktop browser. Let's see how to do it. First, we need to be in the project folder. Let's assume that it is the side menu Hello World. From there, just issue the simple command line. That's it. There's no need to go into the www folder or figure out which port to use. The command line will provide the following options while the web server is running. The most common option to use here is R to restart, or Q to quit when you're done. There are additional steps to view the app with the correct device resolution. First, we need to install Google Chrome if it's not already on our computer. Second, open the link from Ionic Serve in Google Chrome. Then turn on the Developer Tools option. For example, in Mac's Google Chrome, navigate to View, Developer, Developer Tools. As you can see, click on the small mobile icon in the Chrome Developer Tools area and select the desired option. There will be a long list of devices to pick from. After selecting a device, we need to refresh the page to ensure that the UI is updated. Chrome should give us the exact view resolution of the device. Most developers would prefer to use this method to code, as we can debug the app using Chrome Developer Tools. It works exactly like any other web application. We can create breakpoints or output variables to the console. Now let's see how it works. Note that Ionic Serve is actually watching everything under the app folder and transpiling the TypeScript code into JavaScript under the www on the fly. This makes sense because there is no need for the system to scan through every single file when the probability for it to change is very small. While the web server is running, you can go back to the IDE and continue coding. For example, let's open page1.html or any other template file and change the first line to this. Save the file and go back to the web browser where Ionic opened the new page. As you can see, it automatically gets changed. The app interface will change the title bar right away without requiring you to refresh the browser. This is a very nice feature when there's a lot of back and forth between code change and checking on how it works or looks in the app instantly. In this video, we viewed our app using a web browser. In the next video, we'll view our app using the Ionic CLI. Welcome to a new video, viewing the app using the Ionic CLI. In the previous video, we looked at viewing our app in the web browser. In this video, we're going to take a look at viewing our app using the Ionic CLI. So far, you've been testing the web portion of Ionic. Most of the time, you'll need to actually run the app on a physical device, or at least an emulator, to see how the app behaves and whether all native features work. We'll need to have the emulator installed. iOS emulator comes when we run this command, and the Android emulator comes with Android Studio. To test the app on a physical device, we must connect the device to our computer. Now let's see how to do it. Add the specific platform, such as iOS, and build the app. For this, at first we need to have an Ionic template installed. Let's go into the template, which we have, and type the command. As seen, we get the message here as Platform iOS already installed. Since we've been using the standard template from the Ionic CLI, it should have already included the iOS platform in it. Now let's build it. As we can see, if we have successfully built the app, we get the message as Build Succeeded. Now, to emulate the app using the iOS emulator, we'll run this command. As seen here, it will take a while. Awesome, here it is. We can view our app on an Ionic CLI. We can also run the app on any physical device. For example, to run it on an iPhone device, we can use the command as seen here. In this video, we viewed our app using the Ionic CLI. In the next video, we'll view our app using Xcode for iOS. See you there. Welcome to a new video in this section, viewing the app using Xcode for iOS. In the previous video, we looked at viewing our app using the Ionic CLI. In this video, we're going to take a look at viewing the app using Xcode for iOS. As mentioned, we can run the app using Xcode in Mac as well. Let's see how to do it. Start by going to the Ionic folder, then go to Platforms, iOS. Look for the file with .xcode project. Reveal it in Finder and open the file in Xcode. As you can see here, there is no device connected with our Mac. If the device is connected, click on the iOS device icon and select your choice of iOS emulator. Then click on the Run button and we should be able to see the app running in the simulator. We can connect a physical device via a USB port and it will show up our iOS device list for us to pick. Here's the list. We can then deploy the app directly on our device. Note that iOS developer membership is required for this. This method is more complex than just viewing the app via a web browser. However, it's a must when we want to test out our code related to device features such as camera or maps. If we change code in the app folder and want to again run it in Xcode, we have to do Ionic build iOS first because the running code is in the staging folder of our Xcode project. As shown, we can see the staging folder here. For debugging, the Xcode console can output JavaScript logs as well. However, we could just use the more advanced features of Safari's Web Inspector, which is similar to Google's Chrome developer tools, to debug our app. Note that only Safari can debug a web app running on a connected physical iOS device because Chrome does not support this on a Mac. It's easy to enable this capability and it can be done with just a few steps. At first, we need to allow remote debugging for iOS devices by navigating to Safari. Now that we don't see any option here such as Develop, navigate to Preferences, click on Advanced, and click the option Show Develop menu in menu bar. Once done, close the window. Awesome, we've now enabled the Web Inspector. Now let's connect the physical iOS device to your Mac via USB and run the app. Open the Safari browser and select Develop, your device's name, or iOS simulator. Here I haven't connected any physical device, hence we can only see the iOS simulator and click on the option to automatically show Web Inspector. Safari will open a new console just for that specific device as it's running within the computer Safari. Great! As you can see, we'll see a web inspector such as this sample code. We can inspect our elements here. In this video, we viewed our app using Xcode for iOS. In the next video, we'll view our app using Genymotion for Android. Welcome to the video viewing the app using Genymotion for Android. In the previous video, we looked at viewing our app using Xcode. In this video, we'll learn how to set up Android developer environment, on a Mac in this case first. Then we'll install and configure Genymotion for mobile app development. While it's possible to install the Google Android simulator, many developers have inconsistent experience on a Mac. There are many commercial and free alternatives that offer more convenience and a wide range of device support. Genymotion provides some unique advantages, such as allowing users to switch the Android model and version, supporting networking from within the app and allowing SD card simulation. Initially, the first step is to set up the Android environment properly for development. Download and install Android Studio from developer.android.com. Now that I've already downloaded here, you'll see a DMG file such as this. Next, we need to install this. Once done, run the Android Studio. Next, we need to install all the required packages, such as Android SDK. Just click Next at the Setup Wizard screen and click on the Finish button to start the packages installation. Great! With this, we can launch the Android SDK Manager. Click on Install so that all packages are installed. After the installation is completed, we need to install additional packages and other SDK versions. For that, go to the Quick Start screen and select Configure as illustrated. In the Configure button, select the SDK Manager as shown. We can launch the SDK Manager from here. We'll see an option called Extras. Click on Extra and go to Install Packages button. Click the Accept License option and select Install. Now the SDK Manager will give us the SDK path on the top. Make a copy of this path because we need to modify the environment path. This is the path where all the SDK is installed. Now, go to the terminal and type the command. Type E to edit the file, and we can see the file here. Press I to insert. So now we need to insert this line of code. We have to now replace our path to the Android SDK path that we copied from the Android SDK. Save the file and close that text editor. Go back to Terminal and type the source and file name. You should see the output as your SDK path. This verifies that you correctly configured the Android developer environment. The next step is to install and configure Genymotion. Download and install Genymotion and Genymotion Shell from the website genymotion.com. Go to the website and sign in. Once downloaded, go to Plugins in the Android Studio. Click on Browse Repositories and type Genymotion here, and click on the Install button. Now that I've already installed it, we'll click on Restart Android Studio once done. Now that it's restarted, run Genymotion. Just make sure you have a VirtualBox installed on Mac before running Genymotion. Now that we've run Genymotion, we'll see a screen like this. Click on the Add button to start adding new Android device. Now we need to sign in. We can see a number of models here. Let's select any one of them. Here I've selected Galaxy S7 and click on Next. We'll see the devices being added in our virtual devices. It will take a while to download the files and create the device. As you can see, the virtual machine is being deployed. Click on Finish and we'll see the device being added to our virtual devices. Now click on that device and Start. Now the simulator will take a few seconds to start and will show another window. This is just a blank simulator without our app running inside it yet. Now run the Genymotion shell. From Genymotion shell, we need to get a device list and keep the IP address of the device attached, which is Samsung Galaxy S5. So type the devices list here. Now type devices select and the virtual machine ID. Here, as we have only one virtual machine, we'll type 0. You can see the Samsung Galaxy S7 is selected. Next, we need to confirm that it is selected, so type devices ping. With this, it shows that Pong is received. That means our device is selected. Once this is done, let's go to our app folder and type the shown command so as to add Android as a platform for our app. Now we can see that it's already added. Finally, type Ionic run Android. Make sure that our Genymotion and virtual device is running. Nice. So this is our Genymotion virtual device. We can see the app successfully running here. Although there are many steps to get this working, it's a lot less likely that you have to go through the same process over. Once our environment is set up, all we need to do is leave Genymotion running while writing code. If there is a need to test the app in a different Android device, it's easy to add another virtual device in Genymotion and connect to it. In this video, we viewed our app using Genymotion for Android. In the next video, we'll view our app using Ionic View. Welcome to a new video, viewing the app using Ionic View. In the previous video we looked at viewing our app using Genymotion. In this video we'll view our app using Ionic View. Ionic View is an app viewer that you can download from the App Store or Google Play. When you're in the development process and the app is not completed, you don't want to submit it to either Apple or Google right away, but limit access to your testers. Ionic View can help load your own app inside Ionic View and make it behave like a real app with some access to native device features. Additionally, Ionic View lets you use your app on an iOS device without any certificate requirement. Since Ionic View uses Cordova in-app browser plugin to launch your app, all the device features have to be hacked to make it work. Currently, Ionic View only supports SQLite, battery, camera, device motion, device orientation, dialog notification, geolocation, globalization, network information, vibration, keyboard, status bar, barcode scanner, and zip. It's a good idea to check the updated support list prior to using Ionic View to ensure that your app works properly. We can do this in two ways to view our app in Ionic View. You can either upload your own app or load someone else's app ID. To test our own app, follow these steps. Download Ionic View from either App Store or Google Play. Next, we need to make sure to register an account on ionic.io. As you can see, I'm already logged in here. Now go to the terminal, to your app's project folder, and type Ionic Upload. We may need to enter the credentials here if the command prompt asks us. The CLI will upload the entire app and give us the app ID. In our case, it's F289F48C. We'll keep this app to share with other testers later. Open the Ionic View app on the mobile device and log in if you haven't already done so. Now we should be able to see the app name on the Hello World _side menu page in the My Apps page. Go ahead and select the app name. Now select the View app to run the app. Awesome! We'll see that the app interface appears with initial instructions on how to exit the app. Since our app will cover the whole screen of Ionic View, we need to swipe down using 3 fingers to exit back to Ionic View as shown here. If there is no code update, the process is the same except that we need to select Sync to Latest from the menu. To summarize, there are several benefits of using Ionic View, some of which are as follows. It's convenient because there is only one command line to push the app. Anyone can access your app by entering the app ID. There's no need to even have iOS developer membership to start developing with Ionic. Apple has its own TestFlight app in which the use case is very similar. You can stay agile in the developer process by having testers test the app as you develop it. Ionic View has a wide range of device feature support and continues to grow. In this video, we viewed our app using Ionic App. In this section, we've seen a quick overview of creating our app in Ionic 2. Starting with developing our environment, we created our app via CLI and an Ionic creator. We then viewed our app using web browser, Ionic CLI, Xcode for iOS, Genymotion for Android, and finally Ionic View. Looks like we've covered most of it all. Excellent! In the next section, we'll be learning about adding Ionic 2 components. See you there. Welcome to Ionic 2 by HockFan, a video course by Pact Publishing. I'm Mark Thomas and I'll be the voiceover artist for this course. Let's know about the author. HockFan is a technologist with a wide range of experiences in front-end development, cloud computing and big data. He started programming at the age of 12 with Pascal and assembly on the Intel 80286 computer. He learned to start practicing right away, even before figuring out the important concepts. Hock worked on many JavaScript projects in the past by teaching himself the framework using various online resources. He was one of the first few developers who tested Ionic for its feasibility as a JavaScript replacement of the native language of a device. He wrote the Ionic cookbook, which was very well received. He's worked for both startups and large companies. By frequently speaking at local meetups as well as cloud computing/big data industry events and conferences, he learns from other experts. He holds an MBA degree from the University of Washington's Michael G. Foster School of Business. The world of mobile development is fragmented with many platforms, frameworks and technologies. Ionic is intended to fill that gap with its open-source HTML5 mobile app framework that lets developers build native-feeling apps using web technologies, such as HTML, CSS and AngularJS. Ionic makes it easy for front-end developers to become app developers. The framework provides superior performance with deep Cordova integration and a comprehensive set of tools for prototyping, back-end support and development. This course will take you through the process of developing a cross-platform mobile app using just HTML5 and JavaScript based on Ionic 2, which is the latest version of Ionic using the Angular 2 framework. Let's have a quick preview of our course. The first section introduces the Ionic 2 framework with instructions on how to set up the development environment and quickly create and run your first app. The second section walks you through some examples of how to manage pages, states and the overall navigation within the app. The next chapter takes a deep dive into the AngularJS components, directives and the customization of pipes. You'll learn how to leverage the Ionic 2 module architecture to create shared services. After that, we'll look at creating a complex form with input validation, retrieve data via REST API calls, and integrate with Stripe for online payment. The next section will provide instructions on how to embed a video as a background, create a physics-based CSS animation, and bind gestures to the animation state. This sixth section takes a deep dive into registering and authenticating users using Ionic Cloud and sending and receiving push notifications. Following that, we'll use Ionic Native to access native device functionalities such as camera, social sharing, in-app browser, and map. The next section provides instructions on how to customize the app for different platforms using Sass variables. The last section looks into the process of performing the final steps of getting the app published. This video course is a recipe-based solution to all your Ionic 2 related problems, and will help you create cutting-edge real-time apps with ease through simple-to-understand, step-by-step recipes. At the end of this course, you'll be able to solve all your Ionic-related issues through dedicated recipes that will help you get the best out of Ionic. The prerequisites for every section will be given in the respective section. As of now, you just need to make sure you have a working internet connection to download the required software and plugins. So, let's begin this journey together, and I hope to see you there. This is the section Adding Ionic 2 Components. In this section, we'll perform these tasks related to using Ionic 2 components: adding multiple pages using tabs, adding left and right menu navigation, navigating multiple pages with state parameters. Now we move on to the first video of this section that deals with adding multiple pages using tabs. In this video, we're going to take a look at working with the Ionic tab interface and expanding it for other cases. You'll also learn how Ionic 2 structures the tab interface and how it translates to individual folders and files. It's possible to write a simple app with a handful of pages. Ionic provides a lot of out-of-the-box components that allow simple plug-and-play operations. When the app grows, managing different views and their custom data at a specific time or triggered event could be very complex. Ionic 2 comes with some changes in handling state and navigation. In Ionic 1, you could use UI Router for an advanced routing management mechanism. In Ionic 2, Nav Controller will enable the push-pop implementation of the navigation. Since Ionic 2 introduces many new components, you have to understand how these components impact your app state hierarchy, and when each state is triggered. The example used here is very basic, with 3 tabs and some sample Ionic components in each tab. This is a very common structure that you'll find in many apps. In this example, we'll build 3 test tabs as follows. First, showing a simple text-only page to explain where to fit the components. Second, showing a sign-up form. Third, showing a horizontal slider box. Although the app is very straightforward, it will teach you a lot of key concepts in Angular 2 and Ionic 2. Some of them are component decorators, theme, and the TypeScript compiler process. Here is the app where the middle tab is selected. Since this is your first app being built from scratch, you need to ensure that you have followed through the previous section, creating our first app with Ionic 2 to set up the environment and Ionic CLI. If you already had Ionic 1, it must be updated. For this, you can use the same command line as to install, which is shown here. First, we'll create a new Pages and Tabs app using the Tabs template. Then we'll go into the Pages and Tabs folder to start Visual Studio Code as shown. The blank template only gives you a basic page. Open the Finder app in Mac or Windows Explorer in Windows to see this folder structure. Here is the Pages and Tabs folder. You'd only modify what's inside the source folder and not www as in Ionic 1. Everything in the source folder will be built and the www folder will be created automatically. We'll also reserve the folder names and file names as much as possible, since the main goal here is to understand how the tab template works and the areas you can modify. Open the tabs.html template file in Source Pages Tabs folder. Now edit this code. Here, tab title will be 1 and about will become 2, and this will be replaced by 3. Here we'll define the tab icon as water. Second tab icon will be leaf, and third tab icon will be flame. Save this file. The new template only updates the title and icons. This is because this example wants to reserve the naming of tab root variables. You could add more tabs using Ion tab as needed. To add a page, you need to ensure that tab 1 root points to an existing folder and template. Since you will reuse the existing tab structure, you can just modify the home.html template. Make changes in these codes I'm doing. Save the file. Also in the same home folder, edit the home.ts that corresponds to the same template and enter the code here. For the second page, tab 2 root, you'll follow a similar process by editing the about.html template in Source Pages About folder as shown. Edit about.ts in the same folder from before. I've already edited the file. The final file would look like this. Finally, for the tab 3 root page, you can change the templates or show a slider. For that, go to Source, Pages, Contact folder and edit the contact.html. In the Contact folder, you need to edit the contact.ts with this code. Go to your terminal and give the path to the folder that you created. Type the command line Ionic serve to run the app. You can see the HTML page here. Then go to View, Option, Developer Tools. Select the appropriate version. You get the second tab. This is the output. There is actually a lot of new information and a lot of concepts in this simple app. At a higher level, this is how the app is structured. When you run the app, Cordova loads the www.index.html file first to open. All of your code and templates are combined into one file, main.js. The app folder is where most of your logic belongs. It starts with app.components.ts as the bootstrap file. Each subfolder under the Pages folder will represent a page, which is a new concept in Ionic 2. A page consists of an HTML template, TypeScript code, and a .scss file to customize that specific template only. The theme folder will contain variables and customizations at the global level to override the default theme from Ionic 2. Now, let's start with everything inside this app folder. The app.components.ts file only imports all the required pages and components to start the app. This example needs 4 imports. You must always import component, platform and status bar from Ionic, because that will give you the @component decorator to bootstrap your app. A decorator is placed in front of its class to provide metadata for the class. The example tells us that the MyApp class has the characteristics of a component with a template property. Since this is a simple example, we don't need to declare a lot except the template information. Similar to Ionic 1, you can use either template or template URL to point to a local file. Class is another new concept in ES6. However, developers have been declaring class in various programming languages such as Java and C#. In ES6, you can use class to be able to efficiently reuse code with better abstraction. A class could exist within that file context only. Consider the following example. Class example. However, if you want to use that class somewhere else, you have to export class example. In a class, you can have the following f variables such as this.a or this.b, f methods such as do something, f constructor that automatically executes or initializes when an object is created using the class. More information about classes can be found at developer.mozilla.org. Another nice thing about ES6 is the arrow function, which is shown here. It's the same as writing the line in this form. Let's look at an example by passing a parameter. The same code can be written as shown. More information about arrow function can be found at this link. One important thing in app.components.ts is that you must declare a root page. You can see that from the template via root equals root page, and then again in the constructor via this.root page equals tabs page. The square brackets around root mean it's a property of that DOM node. This is a new concept from Angular 2, as it's trying to get rid of using a DOM property such as ngModel, which tends to result in lower performance. The assignment here is to tell Ionic 2 that you'll use tabs page, which was imported earlier, and assign that as the root page. Then, the IonNav directive will look at its own root property to start rendering the page. There seems to be a lot of abstractions and boilerplate compared to Ionic 1. However, this practice is recommended to ensure better separation and scaling. Once you understand how appcomponent.ts works, it's easier to grasp the concepts from the other pages. Let's take a look at the tabs.ts file, because that's where you define the tabs page class. From this file, you need to import 3 other pages, which are shown here. The template for this page is in tabs.html. However, you could also put the template in a string inside the .ts file. So, here's a template. ES6 also introduces a new feature called a multi-line template string. You probably realize that the preceding template string does not have any join or string combine operator. The reason is that you can use the backtick to allow a multi-line template. So instead of doing this, you can now do this. Below the page decorator, you need to export tabs page so that you can use inapp.component.ts and tell the constructor to use tab1 root, tab2 root, and tab3 root, as shown for other pages in the tab navigation. Ionic 2 tab declaration is very similar to Ionic 1. You just have to make sure that the root property is pointing to another page. Tab1 root is actually very simple to understand because it's a text page where you add your own content and design within the Ion content element. You can see that we have added our text content in here. If you want to change the title, we can simply change this line. Tab2 root and tab3 root are very similar in terms of how they're constructed. Ionic 2 gives you the convenience of binding to an event right in the page class. In about.ts, if I enter tab2 root, it will call the IonViewWillEnter function automatically. This is a significant improvement because in Ionic 1 you had to use IonicView.enter on the scope variable. Again, the concept of scope no longer exists in Angular 2. For a scalable app, it's better to separate templates into different files and avoid commingling templates inside the JavaScript code. The template URL must always point to the relative location of the .html file. In contact.html, you can use the slider box and bind to slide the change event as shown. To get an event in Angular 2, or Ionic 2, you have to use parentheses, because the concept of ngClick or similar is no longer available. In this case, if the slide is changed based on IonDidChange, the IonSlides directive will trigger the onSlideChange function in the contact page class. You cannot really run the TypeScript directly without having TypeScript to transpile the code into JavaScript. This process happens automatically behind the scenes when you run Ionic Serve. Also, when you change some code in the project, Ionic will detect the changes and rebuild the files before updating the browser. There's no need to hit refresh button every time. Mozilla Developer Network has a very extensive documentation on ECMA Script 6 that you can find at the link here. For Angular 2 specific information, you can read directly from the Angular 2 documentation at angular.io. So, in this video, we've added multiple pages using tabs successfully. In the next video, we'll add left and right menu navigation. See you there. Hi, this is the second video of the section, Adding Left and Right Menu Navigation. Previously, we've learned adding multiple pages using tabs. In this video, we'll look at how to add left and right menu navigation. We'll create separate apps and edit the code in the apps according to our convenience and requirement. Menu navigation is a very common component in many mobile apps. You can use menu to allow users to change to different pages in the app, including log in and log out. The menu could be placed on the left or right of the app. Ionic 2 also lets you detect events and customize the menu's look and feel further. Our app will look like this on the completion of the task. The app will have 2 pages and 2 menus. You can toggle either the left or right menu, but not both at the same time. In reality, it's much less likely that you'll have both menus, but for the purposes of demonstration, this app will include both menus, as the app will show the different properties of the menus that you can set. The left menu will change the page, and the right menu will allow you to capture the exact item that is clicked on. This app can run on your web browser, so there is no need to have a physical device available. Again, you only need to have Ionic 2 available on your computer. So, let's get started with it. First, we'll create a new left-right menu app using the side menu template as shown, and go to the left-right menu folder. For that, we'll run this command. We'll go into that folder by changing directory. Next, you have to verify your app folder structure to ensure that it's similar to what is seen here. In the source app folder, edit the app.component.ts file and replace with the highlighted code. This is used for an example of ng4 and navigation. You can see that the platform is ready and our plugins are available. Here you can do any higher level native things that we might need. The code OS for resetting the content nav to just have this page. We wouldn't want the back button to show in this scenario. Next, create the app.html file in the source app folder with this code here. This is for the left menu. This is for the right menu. This will disable swipe to go back because it is poor practice to combine STG with side menus. There are 2 menus as siblings in this template. This is the first one, and the second one is this. They're also at the same level as Ion Nav, and not as parent or child. This structure is important for menu navigation to work. Now, let's create 2 pages, for which you only have to modify the standard pages from the side menu template. Open and edit the page1.html template. In the header tag, add the Ion Buttons tag. Add this in the title tag, and make changes in the content tag. In the same folder, open and edit the CSS classes via page1.scss as shown. Note that since you're using the side menu template, it already comes with a second page, for example page 2. There is no need to modify that page in this specific example. Open and edit the template for the second page, that is page 2.html. In this, make changes in the header and content tag. Finally, since we added an SCSS file in the page1 folder, you need to ensure that it's imported in source app folder. For that, you need to add this statement. Save the file. Go to your terminal and run the app. You can see here that you get 2 menus, left toggle and right toggle. Since this app is just an introduction to menu navigation, it won't manage page routing and state parameters. At a higher level, this is how the app flows. First, the app.js loads up both the menu templates in app.html. Second, the left menu will trigger the Open Page function to open page 2. Third, the right menu will trigger the Right Menu Click function to change this .text property and display on the screen. In the app.html template, the left menu has the properties Left and Overlay. However, the right menu has these properties instead. The side property will determine where, on the screen, the menu should show. There are two types of menus. The Overlay option will leave the centre page as it is, without moving. The Reveal option would push the entire screen to show the menu. It depends on your app design to pick different types. Each Ion menu directive must have content equals content declared, because it will use the content area to bind swipe left or right. In this case, it's basically a local variable in IonNav. The use of the Ion toolbar inside the Ion menu is optional, if you want to have the title for your menu. The key to having a menu item displayed is to use Ion list and Ion item. You can loop through an array to display the menu items dynamically. *ng4 is a replacement for ng-repeat in Ionic 1. You need to use #p because it's the same as declaring a local variable named p. This is best practice for variable isolation. Otherwise, the concept is very similar to Ionic 1, as you can grab p.title for each item in the pages array. On the right menu, instead of going to a different page via nav.setRoot, you can just add some text and dynamically display the text inside the menu as shown. So, if the text variable doesn't exist, the Ion card will not show anything via *nglf. For each page, you have to declare the same Ion navbar. Otherwise, you'll lose the top navigation and buttons to the menus. In page1.html, we have declared this Ion header. Note that the left menu and right menu must be the same ID that you used earlier in the app.html template. On the first page, there are two buttons to trigger the menus from within the content page as well. These two buttons also call menu toggle to trigger the menu. The buttons are placed within the Ionic grid system. Since Ionic uses Flexbox, it's very simple to use, as you just need to create Ion column and Ion row. The width property, with a number, will determine the width percentage. For further usage of the Ionic menu, you can check out this site, ionicframework.com. The API document for the Ionic menu is also available at this link. In this video, we've learned to add left and right navigation. Great! In the next video, we'll navigate multiple pages using state parameters. Welcome to the last video of the section, navigating multiple pages with state parameters. In the previous video, we looked at adding left-right navigation. Here we're going to look at navigating multiple tabs using state parameters. App navigation is an important topic because it's at the core of a user's experience. You want to manage the user's expectation on what would happen after they submit a form or after they go to a new tab. In addition, you may want to ensure that the user data is available on the correct page or in the correct state. This could also get more complicated when the requirement of a back navigation is involved. This section will teach you how to work with nav controller and nav params, which are the two important base classes to manage all navigation for the app. This is how our app will look in the end. This app has 3 different examples of how to navigate to a different page and how to pass the parameters. When you click on any button, it will show the second page. The second page basically captures the parameters and displays them on the screen. It also gives you 3 different options to navigate back to the previous page. In this app, you will learn how to use nav controller and nav params, how to use nav push and nav params directly in a template, how to add two-way data binding in an input box, how to use pipe to convert a JSON object to a string and render it on the screen. You only need to have the Ionic 2 CLI available to run this app. First, we'll create a new navigation app using the blank template and go to the navigation folder. For that, we'll type the command start navigation, and then we'll navigate to that folder. This is our folder structure. Edit app.modules.ts in the source app folders, import the required classes, and make changes in the class ng module. The main reason you have to modify this file is to declare other page as a dynamically loaded module via ng module. You'll have to declare other page again in the home.ts file. Now we'll go to the source, app, pages, home, home.html with the code you can see on the screen. Make changes in the 3 Ion card tags. Then we'll edit home.ts file. You can see here that we have imported the required classes. We need to declare the component, and in class homepage we need to add this code. Next we'll create the other page folder in the source, app, pages folder. Now here you can see 2 files in here, otherpage.html and otherpage.ts. You can create the otherpage.html file by right-clicking on the other page folder and then clicking on New File. So in otherpage.html we'll first add header tag code, and in the content tag we'll write this code. In the same folder, add otherpage.ts as well, and add this code in the corresponding classes. Go to your terminal and run the app. Go and change the view to developer tools. You have 3 links here, Other Page 1, Other Page 2 and Other Page 3. When you click on Other Page 1, you'll get this. Other Page 2 gives you 2 options, and Other Page 3 looks like this. Other Page 1 uses both navpush and navparam. Other Page 2 passes an array instead. As you can see, you'll get a text here. In Other Page 3, it gives the sentence passed in the JavaScript file. At a high level, this is how the app is structured. The app will bootstrap via app.ts and load home.html as the root page. Everything in the home folder is your first page. Everything in the other page folder is your second page. These 2 pages are communicated using navparams or navparams from the template. Let's take a look at home.ts. You must import both navcontroller and navparams. For your constructor, you need to do a few things. The this.navcontrol variable will reference the imported navcontroller. You're supposed to bring it in like this in order to use the navigation feature internally. The myString and myJSON are just variables that you'll pass in the parameter to the second page. You also have to bring in the class for other page and make it accessible to navpush later in your template. The goToOtherPage method, as shown, does one simple thing. It will push the page to the current navigation. By doing so, your app will switch to other page right away, and this will include the parameters. The home.html template for the first page is to demonstrate these scenarios. You can use navpush and navparams directly inside the template. You just need to pass the internal object of the class handling this page. So, in this case, you have to pass other page and not other page. Notice the uppercase O. You can also pass a JSON object as a param into navpush. The third scenario is to navigate to a new page manually, as shown, using a method implemented inside the page class. Unlike Angular 1 or Ionic 1, you cannot use the ng model to do two-way binding anymore. The new syntax will be ng model for any input element instead. In your second page, you just need to make the navcontroller and navparams available in the class from the constructor. Let's take a look at your otherpage.ts file. The template for the second page, that is otherpage.html, is very simple. First, the navigation bar on the top is to enable the default back button. The back button is an automatic mechanism in Ionic 2 so that you don't have to worry about when it would show. This code will display the variable content if the state parameter exists. The Ion card leverages nglf to decide whether this DOM should be rendered or not. Since params.data could be a JSON object, you need to convert it to a string to display it on the screen. Angular 1 has a filter, but Angular 2 renamed this feature as pipe. However, the basic concept is the same. This is the logic for converting JSON into a string. The code basically tells Angular 2 to apply the JSON function to params.data and render the output. You could go back to the previous page using the navpop function as shown. Alternatively, you could go back using a directive navpop and put that inside your button. So, those are the possibilities within the Ionic 2 navigation features. For more information, refer to the official Ionic 2 documentation for nav controller at this link. For nav params, you can visit this link. To read more about how Angular pipe works, you can review this page for the previous example on JSON pipe on this site. In this video, we learn how to navigate multiple pages using state parameters successfully. Let's have a quick recap of the section. First, we started with adding multiple pages using tabs. We then also learned how to add left and right navigation. Then, we navigated multiple pages using state parameters. In the next section, we'll be learning extending Ionic 2 and Angular 2 building blocks. Welcome to the section Extending Ionic 2 with Angular 2 components. In this section, we'll perform tasks relating to creating custom components, directives and filters with Angular 2 by creating a custom pizza ordering component, creating a custom username input directive, creating a custom pipe, creating a shared service to provide data to multiple pages. Now we move on to the first video of this section that deals with creating a pizza ordering component. In this video, you'll learn to build an app to demonstrate a custom component with its private variables and template. Most of Ionic's out-of-the-box features are actually pre-built components. Components actually define Angular 2. A component is no more than just a class with self-describing features. For example, UL is a component that you're already familiar with. Previously, we've used various Ionic components such as IonList and IonItem. A component is a decorator, that is, @component. To add metadata to a class to describe the following. Selector. This is the name that is to be used in the DOM, for example, my component. Template or template URL. This refers to the way the component is rendered. Directives. This refers to a list of directive dependencies that you plan to use inside the component. Providers. This is a list of providers, that is, services you plan to use inside the component. Of course, there are many other options, but the preceding 4 options are the most common ones. Let's see how our app will look like. The user will not notice which area is part of the page as opposed to a self-contained component. Your custom component here is the only area where the list is listening to the vegetarian checkbox. This app example could work either in a browser or in a physical device. Let's get started with it. First, we'll create a new My Component app using the blank template as shown and go into the My Component folder. Open the home.html file in the app and replace the content with the code shown here. We'll change the header and content tags. This is your root page containing My Component, which will be defined later. 1. Open the home.ts file. Import these components. Make the changes so that it looks like what is shown here. You simply have to declare My Component as a dependency. A component is basically just a directive with a template, assuming you're familiar with the directive concept of Angular 1. Now let's create the component by first creating a directive. Go to the terminal and type this command. You can see that a component file is created. Create a foo.ts file in the components directory that you just created, and create foo.html in the source components folder. Now, in foo.ts you need to import component, export class myComponent. In foo.html you need to refine item, define card tag with various headers in it, related to veg and other card tag related to non-veg food. Now we'll modify the app.module.ts so that you can declare My Component. Observe the code on the screen. Go to your terminal and run the app using Ionic serve. When I turn off vegetarian, it gives me a list of non-veg foods in my menu. You may wonder why it's necessary to create a component just to toggle a list. The answer is that this is just a demonstration of how you can compartmentalize your app using a component. The key things that you have done are, you created a custom component called My Component, which can be used anywhere, including outside your app. The data within your component is completely private. This means that nobody else can access it without calling a method within your component's class. You can add or change behaviors within your component without impacting other areas outside the component. To create a component, you need to ensure that you import decorator from Angular 2 itself. We've done that here. In your component template, everything is local to what is inside the component class, so you can bind the click event using click. For that, you have to go to the foo.html. Just like Angular 1, you need to use ngModel to declare that you want data.myToggle to be your model. This part is to tell Angular 2 that this is a two-way binding. There are two lists of pizza toppings. The first one is vegetarian, the second one is non-vegetarian. To toggle the visibility of each list based on the data.myToggle model, you need to use nglf, which is very similar to ngif from Angular 1. For more information about components in the Angular 2 documentation, visit this link shown here. So, in this video, we created a component for pizza topping successfully. Awesome! In the next video, we'll create a username input directive. See you there! Hi, this is the second video of the section, creating a custom username input directive. Previously, we've learned about pizza ordering components. In this video, we'll look at creating a custom username input directive in a step-by-step approach, and then understand the concept behind developing it. Since you have gone through the process of creating a component in the preceding section, you may wonder what the difference is between a component and a directive. If you have some experience with Angular 1, you may notice that it had no definition of a component. Starting in Angular 2, there are three kinds of directives: components, structural directives, attribute directives. You may have a mix of both structural and attribute characteristics in the same directive. In this section, you'll learn how to create an attribute directive that can prevent certain characters from being input in the username, as well as showing another DOM node, where it says you are typing username, by toggling its visibility. This is how our app will look. When you click on username, you get the message that you are typing a username. The Go button is there just for cosmetic purposes, and you'll not need to write any code for it. This app example could work either in a browser or on a physical device. First, we'll create a new My Ionic Input Directive app using the blank template, and go into the My Ionic Input Directive folder. For that, we will type the command to start My Ionic Input Directive. It will take some time to create it. To go into the folder, we'll change directory. Next, we'll open the home.html file and replace the content with the code you can see on the screen. We'll make changes in the header and content tag and create a list. As mentioned earlier, the Go button is just an example of the new floating button feature from Ionic 2. All you need to do is include bottom and center in order to position it. These are actually good examples of attribute directives. Open home.ts in the same folder to edit the code. Import component and nav controller export class homepage. Then we need to create the directives folder. For that, we'll go to the terminal and type in the command. Next, create the My Ionic Input.ts file in the directives folder and copy this code into it. You'll see that there are imports done here, and exporting the class My Ionic Input directive. On keypress will not work with Ion Input directly because the actual input element is a child of Ion Input, so we have commented on keypress. In app module TS, you need to declare your new directive as shown. Make sure you've saved all the files. Go to your terminal and run the app as shown. Change your view. This is the app we looked at the start. It looks exactly the same, doesn't it? Great. Here's the username and password. The Go button doesn't work as we discussed earlier. The home page template, home.html, is very typical with Ion List and Ion Item, which contain your input elements. However, there are two important things to take note of. First, there is an attribute called My Ionic Input in the Ion Input component. Observe this code. Second, the My Styles object is now used to toggle the visibility of the P element. This My Styles object is actually a private variable in your homepage class in the home.ts file. With TypeScript, you could assign a type to a variable with a default value. You may also note that My Ionic Input directive should be declared for a dependency to be injected into the template directives. We've declared that here. To create a basic directive, you must import at least directive and element ref in order to manipulate the DOM. However, since this directive has input, that is My Styles, you should also import input in your My Ionic Input.ts. You have selector and host metadata in your directive. The My Ionic Input selector will be queried from the DOM and will trigger actions on that DOM node. For event detection on the DOM, you have to map the event name to the class method. For example, the mouse enter event will trigger a call to the onMouseEnter method in the directives class, which is My Ionic Input directive. Now, let's look more closely in the directives class. The input director is used to declare that you'll bring in a variable from the template. This is the reason why you must have the square brackets in My Ionic Input equals MyStyles. Otherwise, MyStyles would just be a string instead of an expression referring to the MyStyles object from the homepage class. Another interesting thing to note here is the code inside the constructor. The element ref is pointing to the same DOM where you placed your attribute directive. You want to modify the behavior of the keyboard using el.nativeElement on keypress so that special characters won't be allowed. If the user enters a special character, it will trigger e.preventDefault and nothing will happen. The keyboard event is basically discarded. You may wonder why we cannot just use the keypress event and map it to onKeyPress, which was intentionally commented out. The reason is that you're placing the My Ionic Input directive on top of Ion Input, but the actual input DOM is just a child of Ion Input. Therefore, if you listen to the keypress event on the parent Ion Input, you won't be able to bind it. The onMouseEnter and onMouseLeave methods are very self-explanatory because they just toggle the MyStyles show username variable. Again, this MyStyles object is just a reference back to the MyStyles of homepage. So if you change the variable here, it will change at the homepage's level as well. For more information about Angular 2's directives, you can refer to the official documentation at angular.io. Since this is the first section where TypeScript appears, it might be helpful to go through the handbook at TypeScript lang. In this video, we've learned to create custom username input directives. Great! In the next video, we'll create a custom pipe. Hi, this is the third video of the section Creating a Custom Pipe. Previously, we learned about creating a username input directive. In this video, we'll look at creating a custom pipe using the pipe decorator. Pipes are also a feature of Angular 2 and are not specific to Ionic. If you're familiar with Angular 1, a pipe is exactly the same thing as a filter. The main reason you might want to use pipes is to display data in a different format in the view. You don't want to change the actual value in the component. This makes things very convenient because you don't have to decide on the specific format within the code, while leaving flexibility in the view layer. Here is a list of some useful built-in pipes. Async pipe, date pipe, number pipe, slice pipe, decimal pipe, JSON pipe, percent pipe, uppercase pipe, lowercase pipe, currency pipe, replace pipe. Let's look at the app we're going to create. While the app interface is very simple, this example is to show you how to create a pipe to extract object data. There is no need to test in a physical device because the Angular 2 pipe will work just fine in the web browser. First, you need to create a new custom pipe app using the blank template and go to the custom pipe folder. Open the home.html file and modify the content with these code parts highlighted. You can quickly see that the template uses the userExtract pipe to render the correct information. Then replace the content of home.ts with the code here. Import the correct components, make changes in the component tag, and export the class that has constructor. You don't have the custom pipes.ts file yet, so you need to create it next. Create the utils folder by using the command on the terminal. You can call this folder anything. However, since sometimes pipes are considered utility functions, let's call it utils. Create the custom pipe ts file in the utils folder and copy this code in it. Next, we need to add userExtract pipe to app modules ts by replacing it with the code shown here. Go to your terminal and run the app. After changing the view, we see our app. We can see our formatted and unformatted list here. You can use an Angular 2 pipe in the view to simply convert or transform any value to a desired value. There's no limitation on how you want to structure the pipe. Angular 2 automatically detects the pipe sign in the template and turns the value in front of it into an input. To create a pipe, you must import the decorator and provide a name. The input from the template is the following value parameter. The value returned by the transform method will be the output to the view, as shown. In this example, you're taking a parameter for the pipe to process, as illustrated. For example, this is what you had in the home.html template. Each parameter is placed after a colon. Then, within your pipe class, you can refer to it using argument. The rest of the code is very simple. If it's first name, take the first word after splitting by space. If it's last name, take the last word. If it's age, subtract the current year from birth year. Of course, you could have more complicated scenarios with pipes. However, the overall recommendation is to keep things simple at the view to ensure rendering performance. If you need to do heavy processing, it's best to handle it as a separate variable. To understand more about Angular 2 pipes, you can check the official documentation at this link. In this video, we've learned to create a custom pipe. Great! In the next video, we'll create a shared service to provide data to multiple pages. Hi, welcome to the last video of this section. Previously, we learned about creating a custom pipe. In this video, we'll look at creating a shared service to provide data to multiple pages. When you develop an app that involves a lot of pages and communication to the backend, you'll need to have a way to communicate across pages and components. For example, you may have a service to request user data from the backend and store it in a common local service. Then you'll need to provide a way for the user to update their user data and see the update in real time. When the user navigates to different pages, the same information will be pulled and rendered as well without making multiple trips to the backend. This is a very common scenario that requires the use of injectable decorator in Angular 2. This page uses the same service as the preceding page and references the same date with the name and age. In this section, you'll learn creating a service using injectable, sharing a service across multiple pages, detecting changes using getters and setters inside the service. This app example could work in either a browser or on a physical device. First, we'll create a new shared service app using the blank template. For that, we go to the terminal and give the command for it. Then we go to the shared service folder. You'll need to make several changes in the directory because you have two pages and a common service for both. Let's start by modifying the app component TS file so that the root page is pointing to page 1. So I'll make the changes highlighted on the screen, and your final code will look like this. Create a directory for the page 1 file in your terminal. Create your first template, page1.html, in the page 1 folder. Make changes in the header, content and card tags. Create page1.ts in the page 1 folder as seen on the screen. Export class page1, which has a constructor. You can see that we have still not defined a user service. We'll define this class later. Please note the file extension is .ts and not .js because you're going to use some TypeScript specific features, such as getters and setters. Similarly, create the page 2 folder using the command we used earlier. Next, add the page2.html template in the page 2 folder as well. Create page2.ts in the page 2 folder. In the page1.html, make the changes highlighted in the code. This is your second page with the same name and age information with this code. Create the services folder with the services command. Put user service in the user.ts file in the services folder. You need to add this injectable. Define the getName, SEName, getAge and setAge functions. Now the user service error has been removed. Save this file. Open and edit appmodule.ts so that you can inject user service as a global provider. First, you need to import this. In the ng module, you need to make a declaration and export the class app module. Save this file. The error for user service has been removed from page 1 TS and page 2 TS. Verify your folder structure looks like this. Go to your terminal and run the app. You can move from page 1 to page 2 and then back, and the data persists across the pages. In general, if you want to use a common service across multiple pages, you must inject it at the highest level. In this example, you put user service as a dependency at the start of app module TS. After that, other pages within the app can start using this common service without having to re-inject it. The main reason is that whenever you inject a service or class, it will instantiate a new object, which ends up erasing all the existing data in memory. If you want to keep the data persistent across pages, it should be in the parent app to avoid re-injection. To use the user service in each page, you just need to import it, as illustrated in the shown code. The way to bring in the service is to put the referencing in the constructor, page 1 TS, as shown. This will pass down the user service reference to a local private variable of the page, in this case, this.user. From the template standpoint, there is no difference between using user.name and user.age to inject data. Now, let's take a look at user service. Actually, there are several things going on here. First, you need to import injectable from Angular/core. Note, don't forget the parentheses in injectable. Second, if you want to use getters and setters, you need to make separate variables called _name and _age to store the data. Then you can use the getSet method to do additional processing when other pages access or set the variables in this common class. If you change the name or age from page 1, you can see these logs in the console. This feature is very beneficial since you can use this as a replacement for watch or observable. If you recall from Angular 1, you have to use $scope, $watch for a similar approach. For more information about Angular 2 services, visit the official documentation at angular.io. You can get great instructions on many techniques for component communication at this link. This brings us to the end of this section. Let's summarize on the key points that we learned. Starting with creating a customized pizza ordering component, we created a username input directive, then a pipe and a shared service to provide data to multiple pages. Great! In the next section, we'll learn more about validating forms and making HTTP requests. Welcome to the section on validating forms and making HTTP requests. In the previous section, we learned about extending Ionic 2 with Angular 2 components. In this section, we'll see how to validate user inputs such as text, number and required versus not required, and communicate the data to another page, learn how to render data without having an actual back-end, and also how to process payments using Stripe. Now we move on to the first video of this section that deals with creating a complex form with input validation. In this video, we'll learn to build an app to demonstrate form validation using ngForm and ngControl. All mobile apps require taking user input and sending it to a back-end server. A simple example is filling out a form, such as a user registration or contact form. The information is validated against a set of rules before being sent to the back-end. Also, there are many other scenarios where the information is captured based on user behavior from the app, such as where they touch or how much time they spend on a certain page. Regardless, you'll run into many send and retrieve data scenarios. As we'll see in this section, all of these topics are actually available natively in Angular 2. However, since Angular 2 has a lot of changes compared to Angular 1 in terms of processing data and working with the back-end server, it's worth covering these topics in detail. This is the form that we're going to create. If the user tries to submit without providing valid information, the form will show the error shown here. Basically, the name field is required. The phone field is the number type but is optional. The comment field is required, and the user must enter at least 4 characters. Of course, this is just for demonstration of the input length. The user finally must agree to the terms and conditions via the toggle input. After a successful validation, the user will be taken to the second screen with a summary of the previous screen as shown here. This app example could work either in a browser or on a physical device. However, you can optionally connect your physical device to verify the phone field for number keypad. Now let's see how we can go about this. Let's create a new form validation app using the blank template. At first, go to the Ionic folder and type this command. Type Ionic start myform validation blank --v2. So this is the command you need to type to create the myform validation app. Now you can see it's being created. It will take a while to create all the packages. You can take a break and return when it's done. Now that it's done, open the myform validation app in our VS Code. You can do this by typing code space dot. Go through the myform validation app shown on screen. Once created, go to the folder. Type cd myform validation. So once we are there, you can open the myform validation app in the VS Code. For that, type code space dot. As you can see, it directly opens in the Visual Studio Code. Now we need to edit some of the files. Open the app modules.ts file, which is in source app. Type import. This is the file wherein the code needs to be replaced with code you can see on the screen here. Once we have imported the thank you page and the myform service, we need to include the thank you page in declaration. Also ensure that you have included thank you page in the entry components and set the myform service as the provider. Once done, save the changes made. You may realize that there is a common service to be used across the app called myform service here. This example also has a second page called thank you page. Now let's create the service by first creating a directory as shown. Go to the terminal and type this command. Now moving on to the VS Code, you can see that the services folder is created here. So we need to create myforms.ts file. Right-click, new file, rename it as myform.ts. Once done, you have to add lines of code here. Here we are importing the injectable from the Angular core and creating the annotation of the injectable, and then creating a class called myFormService, which contains three elements, which are name, phone, and comment. Lastly, we're creating the constructor. Once done, save the file. This example will keep the service components simple for demonstration purposes. Open and edit the home.html that is in source, pages, home template as shown. We need to replace the code with this. As you can see, here we're creating the contact form that has a name, phone and comment as the input parameters, and lastly we'll have a submit button along with a toggle button. One would need to agree to the terms and conditions in the toggle button. Once done, save the file. This is probably the most complicated part of the form validation process because there are many places where you have to embed validation logic for the input. Now open the SCSS file and replace the content of the home.scss file with the code you are going to see here. Save the file once complete. Now we need to edit the home.ts file. As you can see, it's in the same folder, and replace this content with the code here. Here we have imported the thank you and the my service form pages. You may note that there isn't much validation code in the JavaScript part. This means that the template takes care of a lot of the validations. There is also an import command for a thank you and a myform service page, which we'll have to create next. Here we are specifying the name, phone, comment as false, and then we would be creating an activity on the onSubmit button, and give the command to redirect to the thank you page on clicking the submit button. Now let's create the thank you folder. Let's go to the terminal and type this command. As you can see, in the Pages tab, a thank you folder is created. Now create a thankyou.js file in the components directory that you just created. Here, let's add some lines of code. Here we're importing the component and the myform service. We're creating a template URL of thankyou.html and then calling the constructor of myFormService and giving the form data. This page just renders the data from the myFormService service, so you can keep it very simple. Let's create thankyou.html in the same folder as illustrated. Here we would need to add these lines of code. Now let's create one more file called thankyou.scss in the same folder as shown. This will contain a CSS line of code. These are the CSS commands that we need to add in the SCSS file and save. Now let's edit the app.scss file to ensure that you include both the .scss files in the 2 pages. Let's go to the app. Here's our file. They're the 2 commands that need to be included in the SCSS file to get it working. Save all the files. Once done, go to your terminal and run the app with Ionic serve. Awesome! As you can see, we have successfully created the contact form. Time for some testing. Let's say my name, contact number, and here I write a comment. Say My App and check the toggle button agreeing to the terms and conditions. If this is not done and we try to submit, it will generate an error message. Now you can see the thank you page is displayed with the information you have entered in the contact form page. Yes, we have successfully created our app. Now we'll see how it works. Go to the code editor. If you look at the home.html file where most of the validation code is located, just look at the structure of this page. It's very typical. You have Ion navbar with Ion title. The form element must be inside the Ion content area. It's a requirement to use the form element for Angular 2 validation to work. Otherwise there will be no submit event and you cannot catch errors for each input. We can see the form variable here. To assign a local variable on the fly, you use the hash sign. This means that you want the f variable to refer to ngForm, which is automatically created from Angular 2. This is a special object that contains everything related to the current form. You're advised to use noValidate to bypass the default HTML5 validation, because you're using Angular 2 for validation instead. Otherwise, the form will acquire conflicts. The ngSubmit is pretty much an event to trigger the onSubmitF function, whenever the button with type equals submit is touched or clicked. When you submit the form, it will pass the f variable along so that you can process the object inside the onSubmit method. The form template consists of just Ion list and Ion item. You just need to know how to validate each input and display the error. Let's use the name field as the first example. This is the Ion input for name. The error is displayed in the div tab. To validate, you must assign the name of a local variable name. This is to refer to that input using f.controls.name in other areas. Recall that the f variable has been declared previously as the ngForm object. Here is a view of how the ngForm is structured. You can view this using the Chrome Developer Console because the code actually gives this output when you submit the form. The error message name is required will be hidden when either of these conditions takes place. The form has not been submitted yet, otherwise people will see the error message right away before they even type in something. This is not a good user experience. To check for this, you have to use a temporary boolean called isSubmitted. The f.controls.name.pristine variable means that the input has not been modified. The opposite of this would be f.controls.name.dirty. The f.controls.name.valid variable is true. However, you cannot check this right away because if the input is empty, the name object does not yet exist. That's why you need to check for the existence of f.controls.name before checking for valid boolean. There is no need to check the phone requirement, so you just need to assign name and a model as shown. For the comment field, there is a need to validate using both required, min length equals 4. You may think required is unnecessary because if the length is 0, Angular 2 will trigger an error flag. However, that's not true. When the user doesn't enter anything in the input will have no length because the variable doesn't exist. That's why you need to check for both scenarios. The error message for the comment field is quite interesting because it shows the number of characters the user needs to enter. This code helps with that. The main idea here is that you only want to show this div when the form is submitted, and it's pristine via f.controls.comment.pristine. This means that the user has not yet entered anything in the form. You also want to show the message when the form is dirty and has errors via f.controls.comments.errors. If you inspect the console, you can see a list of many detailed errors under the f.controls.comment.errors object. In order to tell the user how many characters they have left to enter, you have to first check f.controls.comment.errors.minLength, because if that variable doesn't exist, there is no error or the comment input is empty. If you do not check for this, you will get a parse error later on. In our home.ts file, the onSubmit method must toggle the isSubmitted boolean to true. Then we'll have to do a general check for myForm.valid and myForm.value.tos. The reason is that there is no way to validate a toggle button in Angular 2 since it doesn't make sense to do so, as it cannot be required. Therefore, you have to do a custom validation here to make sure it's true in the form. This means that the user has checked the Agree to Terms and Conditions toggle. This is a minor detail that could be a bug in Ionic 2, currently beta 21. For each toggle button, it acts as a type equals submit button by default, since there is no type attribute assigned. That's why you need to cancel the submit event by calling prevent default method. The thank you page is very self-explanatory because we just passed the form data in the template by getting the data from the myFormService service. For more information, I'm going to provide a few links here. For more information about form from the Angular 2 documentation, you can visit this site and the ng form site. The Ionic documentation has its own page specifically for Ionic input components, which is this site on ionicframework.com. It also has a good list of HTML5 input types that you can use for validation or keyboard enforcement, which you can find at this link. In this video, we learned to create a complex form with an input validation. In the next video, we'll retrieve data via a mocked API using a static JSON file. Hello and welcome to a new video of the section, retrieving data via a mocked API using a static JSON file. In the previous video, we got to know about how to create a complex form with input validation. In this video, you'll learn how to call a REST API using the HTTP service. The API endpoint will just be a static JSON located on your local machine. You'll also learn how to leverage placeholder images to meet design requirements. As a front-end and app developer, you're often working with a team where someone else is responsible for the back-end APIs. However, it's not always possible to have the back-end available when you're developing for the front-end. You have to simulate the back-end in scenarios where the final back-end APIs are not ready. Our app will show a list of image feeds and a description. This is our final app and how it will look like. This app example would work either in a browser or on a physical device. However, the fake backend server must be running on your local computer. First, let's quickly create the fake backend server. For that, you must install http-server. Type in this command in the terminal and enter. You can see the npm server is being installed. Once done, create a folder to store your .json file. Let's create a mock REST using the make directory command. Now we need to create the test.json file and fill in the content for the REST response. So let's open this in the code editor. Once done, create a file called test.json. This is the code to be added in test.json file. Basically, whenever you send a REST request, you should receive this code content as the response. As your backend developer updates the REST response, you can always change the content of the test.json file accordingly. Now let's start our backend server by calling HTTP server from the terminal in the mock REST folder. Go to the terminal and type this command. Great! Here we can see it's running on port 8080. Open your browser and visit localhost 8080/test.json to verify, and you can see the JSON content. If not, you probably have a port conflict with another web server. You need to ensure that there is no other application using port 8080. After completing our backend, open another terminal window and create a new MyREST backend app using the blank template. Now let's create the MyREST backend. For that, we have to use the Ionic start command. Here you can see the MyREST backend app is being created. Once done, go to the MyREST backend folder. Here you must not stop the backend server or create an Ionic project inside the mock REST folder. They're two independent project folders. Now open the MyREST backend in the code editor. Now let's open the home.html file and replace the content with our own code. Type title as home and replace the Ion content with the code as shown. This app example uses free photos from the site source.unsplash.com/category, because you can easily query to get random photos that meet your need. Now open home.ts and edit it. You need to import quote service from services/quote. Once we've imported the quote service, we need to add the nav controller and add the quote service here. You also have to add a couple of lines here. You've not created the quote service yet. However, you probably know that this service will call the fake backend server to get the JSON content using the getQuotes method. Let's do a small modification of the style sheet in the home.scss and type the code after me. You'll get the color with this code. Save the file. Next, create the source/services folder with the make directory command. Going back to the terminal, you can see that a services directory has been created. So, we need to create the quote.ts file in the services folder. Here, you need to add some code. This is the code we have added. You'll find the code in the code bundle provided. Here we're importing the injectable from the Angular core, HTTP from the Angular HTTP. Then we're creating the quote service and we get the codes from the test.json file. Once done, hit save. Next, we need to edit the app.modules.ts file to declare quote service. So open the file. Replace the line of code as shown. You can see we have added one more import, which is the quote service, and we've changed the provider as the quote service. Once done, go to the terminal and run the app as illustrated. Oops, there's an error. The error is due to this line you can see in home.ts. Here I'm calling the getQuotes from the quotes function. Now go back to Chrome and build our app. Awesome. Here you go. We can see our home page with images and quotes of the JSON file. This is the app which we've built. Now, if you see an empty page here and the console shows some error, this means that your browser, in this case Chrome, does not allow calling the REST API from localhost 8100 to localhost 8080. For this, we would need to install the Allow Content Allow Origin CORS plugin from this site for Chrome. After that, turn on CORS. Refresh your browser to see the updated app. As you can see, it takes quotes from the JSON file. Let's take a look at how it works. Your fake backend simply returns any file in the current mock REST folder. As you get more sample responses from the backend developer, you can copy them into this folder to provide additional backend endpoints. Please note that this section does not provide examples of how to handle post and complex scenarios where the responses depend on the request parameters. You may want to keep the code to handle temporary cases as simple as possible since they are not production code. The recommendation is to return the same content for each post request as well. Going back to the editor again, let's take a look at the quote.ts file, because it's the main place where the HTTP request is made. First, you need to import the injectable and HTTP. The injectable decorator is used to allow other pages and components to use quote service as a dependency. The HTTP service or class is provided by Angular 2, not Ionic 2, and this is similar to the $HTTP provider in Angular 1. However, instead of returning a promise, HTTP will return an observable object so that you can subscribe to it. The getQuotes method is the most important part of this file. The this.http object must be injected from a constructor. Then it will trigger get via this.http get, just like the $HTTP provider. However, there is no .then function, but in Angular 2, you have to subscribe to the object. A new feature of ES6 is the arrow function, as you can see via res. This is similar to the lambda function in other languages, for example Python. There is no need to declare the name of the function, and you don't have to type function each time. In addition, it automatically passes the parameter, res in this case, and the this context inside the function. Please note you can read more about the arrow function from TypeScript documentation at the site www.typescriptlang.org. The REST response from your fake backend will be assigned to this data of the quote service as shown. Another nice trick in the home.html template is to display a grey placeholder for the photos instead of pushing down the content when the photos are downloaded and rendered. This screen shows a quick example of what you'll see before the photos are loaded. In order to tell the image tag to have an exact size, you have to do a height calculation using height equals mycard.clientWidth times 390 divided by 600. This is because the photo is 600 by 390. The myCard object is a local object created from IonCard. This myCard object will have access to all properties of the IonCard DOM, including the width via client width. You have probably noted that this is just pure JavaScript and has nothing to do with either Ionic or Angular itself. For more information about the Angular 2 HTTP provider, you can visit the official documentation at angular.io. In this video, we've learned how to retrieve a data via mocked API using a static JSON file. In the next video, learn how to integrate with Stripe for online payment. Welcome to the last video of the section, integrating with Stripe for online payment. In the previous video, we looked at retrieving data using a static JSON file. In this video, you'll learn how to integrate with a real back-end service for the payment process. For creating an account on Skype, insert your details and access the token variable. Earning revenue is an important aspect of creating an app. While there are many other methods of collecting payments, Stripe is a common payment system and can integrate very well with Ionic. In addition, there is no need to provide a high level of security and compliance, that is PCI, since you will not be storing the credit card information. Your app will not process via a real payment method because you can use a public test key from Stripe. The app will ask for a few fields to create a token. This is how your app will look like. If you touch the Pay $20 button, it will take you to the next screen where you'll get the payment token as shown here. Please note, actually there are additional steps for your backend to call Stripe to authorize and process the transaction. However, it's not within the scope of this section. The Stripe document has a good tutorial page on node.js at stripe.com. There's no need to test in a physical device because Ionic 2 and Stripe will work just fine in the web browser. Let's see how this can be done. If you don't have a Stripe account, you need to register on https://stripe.com to create an account. Log in and go to the dashboard. This is my dashboard that's seen here. Click on your username on the top right and select Account Settings. Now select the API Keys tab. Copy your test publishable key somewhere because you need to use it for your JavaScript code later. Now go back to the terminal. Create a new Stripe payment app using the blank template and go into the Stripe payment folder. You can see the Stripe payment folder is already created. With the magic of video editing, it's already done so soon. Once done, go to the Stripe payment folder and open the folder in the code editor. Now, open the index.html file and insert the line in the body tab as you can see here. This is to load the Stripe object globally in your app. This is not the recommended method with Angular 2 because anything that is used within a component must be imported via the import instruction. However, at the time of recording this video, Angular Stripe is unavailable for Angular 2, so there is no way to do this properly. The preceding method will work just fine. Save the file, open the home.html file and modify the content. Stripe only needs the credit card number, CVC and expiration to create a token for charging. The customer name and address are optional, so you don't need to include them here. Now let's replace the content of the home.ts file. Here I've entered the new code here. The code file is available in the code bundle. You need to change your test publishable key here by replacing your Stripe public key with your own key that you copied earlier. Now let's go to home.scss file from source, pages, home.scss and replace the line of code. Once done, hit save. Next, we need to create the thank you page that shows the token ID by making a new folder called thank you in the source pages folder. We'll use the make directory command for that. So let's go to the editor again. So we can see that the thank you folder is created here. Create the thankyou.html file in the thank you folder and copy this code. In reality, there's no need to show the token ID to the user. This is just an example to get the token ID to charge. Let's save it. Now let's create the thankyou.ts file in the thank you folder and add this code. Here we're importing the component and the name controller, and we're creating the annotation of @component and creating the thank you page. Once done, create the thankyou.scss file to modify the theme. So let's create the file. This is the command you need to add. Save the file. Since the thankyou.scss file is new in the project, you need to include it in the source app.scss. Here, you need to add this import. Once you include this line of code, you need to add to this page in app.scss and save it. Now it's time to modify the app module ts file. Open and edit source app.module.ts to declare the thank you page. Also add the thank you page in the declaration. Since there is no provider, we can skip this part. Save the file. Now that everything looks good, go to your terminal and run the app. Oops, there's an error here. Let's check what went wrong. We missed the opening bracket here. Now hit save and run the code. Nice. As you can see, the app is already built here. Let's input the credit card number. For the purpose of testing, you can use this as the credit card number, 123 as CVC, and 12/2017 as the expiration. Click on Pay $20 and it will take you to the next screen where you'll get the payment token. Your token will look like this. Let's see how the Stripe charging process works. The user fills in the payment form and clicks on the Submit button. The front end, your Ionic app, will call the API to Stripe using the Stripe object and send along all the payment information. Stripe will return a token ID, which is basically a way to confirm that everything is correct and you can charge the card now. The front end will use the token ID to send to its back end, without the credit card information, to authorize the charge. The back end will call another Stripe API to say, I'm going to charge now. Stripe will return the success event to the back end at this point. The back end will then return the success event to the front end, and the front end would render a new page, such as the thank you page. As discussed previously, this video will not cover the back end portion of this app because it doesn't focus on Ionic. You can build the back end using any language such as Node.js, PHP or Python. Let's take a look at the home.ts because the majority of Stripe API processing is located there. First, you need to do a declare, as illustrated, because Stripe is a global object that was included in the index.html. If you don't do a declare, the app will still run, but you'll get an error from TypeScript. When the user submits the form, it will trigger the onSubmit method. When you call stripe.card.createToken, the Stripe object will trigger an API call in the background to stripe.com with the JSON submitted. You may realize that this example does not use ngModel at all, but you can get the form values directly from within ngForm. This functionality is accomplished by the following code in your home.html. Once Stripe returns your token ID, it will call the arrow function. The reason for using the arrow function here is because your code within the Stripe response handler method needs the this context of the homepage class. This is a nice way to access the token variable. Observe the code here. The response.id will have your token ID from Stripe. Otherwise, you can handle the error using response.error.message. In this example, since it only passes the token ID to the next page, you can simply send it as a parameter, token::this.token. In your thankyou.ts, you can access the parameter token using this code. To understand more about the Stripe API, you can check out the official documentation at stripe.com. Also, there are more examples from other languages that you can experiment with at the site stripe.com/docs/examples. In this video, we've learned how to integrate a real back-end service for online payment process. In this section, we created an app for input validation, and then retrieved data via a mocked API, and finally integrated with Stripe for online payment process. In the next section, we'll cover how to add animation to our app. Hi and welcome to the section Adding Animation. In this section, we'll learn how to do basic animation using video and CSS, embed a full-screen video as background, start utilizing physics-based animation to create interesting interactivity, also bind the gesture frame by frame for animation to happen instantly during a swipe event. Now we move on to the first video of this section that deals with embedding full-screen inline video as background. In this video, you'll learn how to add a video with autoplay in the background and learn to use animate.css to add a custom animation to the app header text. Today, there are many apps leveraging video as an animated background for the introduction screen. This makes the app more interesting and creative. The users feel that they are welcome to the app. This tactic is great to impress new users and encourage them to come back. This app example could work either in the browser or on a physical device. However, it's optional that you connect to your physical device to verify that the animation is playing correctly in the background. Let's get started. Create a new video intro app using the blank template as shown, and go to the video intro folder. Type Ionic Start to create the blank app. As you can see, the app is being created here. Now that's done, let's go to the video intro folder. We need to have our video ready at this point. However, for this example, let's download a free video from a public website that does not require a license. Navigate to the website coverr.co. You're free to download any video. In this example, we'll be using the blurrypeople.mp4 clip. Go to People and search for Blurry People. Download the video to your computer. Extract the zip file from Downloads. It will look like this. So here there are two files that we're going to use, the MP4 file and the WebM file. We need to add this to the Sources and Assets folder. So let's go to the terminal and open our app in the editor. Type code dot. Now we can see the Visual Studio Code that is opened here. We need to save the video in this folder. For that, let's copy the folder from the download and paste it in the icon folder here. As you can see, I've already added this. Now, open the source index.html file and replace the content with this code and save the file. Basically, the main difference with the original index.html file is that you want to include the Google Lobster font for the heading text and animate.css for animation. For the main templates, you need to modify the home.html file in the source pages folder and replace it with the code I'll show you here. You need to change the TIL and replace the ion content with this code. Now there are only two important items on this page, the video and the header with subheader. Next, we need to open and edit the home.scss file. Let's go to home.scss file in the same folder and replace it with the code shown on screen. Save the file. All animation is done using CSS, thus you don't need to write any code for the JavaScript file. Now, open the config.xml file and add the following line within the widget tag, adding one or more preference settings to the value to true. Let's go to the terminal and run the app with the Ionic serve command. Awesome, you can now see the app here. Initially, I wasn't able to run the code due to this path. You need to give a specific path where your blurrypeople.mp4 and blurrypeople.webm is located in your app folder. Here it was assets, icon, blurrypeople.mp4 and blurrypeople.webm. Now let's see how this works. Starting with home.html file because that is the only page where you added the animation. This is just a typical video tag in HTML5. However, there is a new attribute called WebKit plays inline. This means that you want the video to play where it is on the HTML page and not open it up full screen with the play control. The reason is that you want this video to play in the background while you can animate text on top of it. This is the reason you need to enable this feature by setting Allow Inline Media Playback in config.xml. The second item in this template, that is the div tag, is your header and subheader. Note that there are animated and zoom in classes included. These are the required classes for animate.css to kick in. If you run the app, you'll see that the text starting to appear from a smaller font to a bigger size. That is a zoom-in effect. The home.scss file is important because it has a lot of animation logic. Let's take a look at the header text first. One interesting thing here is that the use of the text shadow attribute. This is because you want to create a thin border line around the text so that your white text can be easily seen on top of a light background. To set the video to full screen, you need it to have a negative index, so that it's below the other layers. Also, the height must be 100%. Finally, in order to position the text vertically in the center, you have to create this class. The center class forces the element to have top of 50%, but then push the Y position minus 50% to reset the vertical pivot of the div tag in the middle area. You'll rarely need to customize such classes, thus it's good to keep the center class handy for future use. Great! We can successfully see the app running here. In this video, we learned how to embed an inline video in the background. In the next video, we'll be creating a physics-based animation using Dynamic.js. See you there. Hi, this is the second video of the section Creating a Physics-based Animation using Dynamics.js. In the previous video, we learned how to embed a video in the outline. In this video, we're going to show how a bouncing button can show and hide a top quote box. It also uses physics animation. Using physics-based animations can make your app more interactive and lively, which helps attract and retain more users. There are many methods to add physics to your component animation. For example, you could even use the CSS animation timing function to add property values, such as ease in, ease out, or cubic Bezier. However, it's easier and better to use an existing JavaScript-based physics animation. Dynamics.js is one of those JavaScripts that comes with utilities and performance. Using native CSS physics features is not actually a good practice, as it comes with a frame per second penalty on mobile devices. The app that we'll be creating will show a bouncing button, which can show and hide a top quote box as seen. It also uses physics animation. This app example could work either in a browser or on a physical device. However, it's recommended that we run the app via our physical device to test for performance. So, let's get started. Open a terminal window and create a new spinning button app using the blank template with the Ionic start command. And go into the spinning button folder. Let's go to our code editor. Great, we can see the app here. Now we need a dynamicsmin.js file here for our app. Therefore, go to the website dynamicsjs.com and click on Download. You'll be redirected to a GitHub folder, and we'll let you download the dynamicsmin.js file. As you can see, I've already downloaded it here. Copy this file and paste it in the Source Assets folder. Nice. We can see our file in the Assets folder. Now let's go back to the editor. The next step is to open and replace the code in the index.html file. Replace the code as you can see. Here we're giving the dynamicmin.js path in the source folder. The key part of this file is to ensure that the dynamicsmin.js file is included. Now let's open and edit the home.html file to replace the content. Here we need to replace the header first and replace the content of Ion content with this line of code and save the file. There's no need to have header navigation in this app because it will just be a single page. Now open the home.ts file. Here at first we need to declare the dynamic variable, so let's add this line of code while defining the home page. As viewChild is not defined yet, so we need to define it as well. You also need to add viewChild in the import so as to avoid errors. Save the file. Now we need to edit the home.scss style sheet. Replace the code as shown. And save the file. Go back to your terminal and run the app with the Ionic serve command. Awesome, we can see the app running in the browser. Now, when you click this button, it will pop up a quote. Now let's see how it works. The main concept behind the physics animation in this app is the dynamics animate method from the Dynamic.js library. So let's start with the button in the template. Going to the template, this is our dynamics.min.js file. This is your floating button that you can click to create a nice bouncing effect by calling the animateMe method. The simple logic here is as follows. If the button is animated, isAnimating must be true. Once it's true, any additional click will not trigger the animation since we don't want the physics to kick in multiple times. If the top quote bar is displayed, isQuoteShown must be true, otherwise it will call a different animation to hide it. You can pass many options in the dynamicsAnimate method. For example, the button will use dynamicsBounce as the type, thus it will bounce up and down on each click. You can also specify the duration to be applied in the animation process itself. Therefore, after the animation is done, it will trigger the callback in the complete function as illustrated. So, this is our animateMe function. This is our callback method. An important thing to keep in mind is that Dynamics.js must refer to the DOM JavaScript object itself and not the DOM node or Ionic object. That's why you have to use el_element ref.native element to point to the native element object instead. For the quote box, it uses a local variable called myCard in the template as shown. This is the myCard variable. You must refer to this variable using the viewChild decorator, so that page knows to include it as a dependency. To learn more about Ionic 2's floating button, go to the link ionicframework.com. Also, if you're interested in learning more about native CSS physics-based animation, visit this website. In our video, we created a physics-based animation for our app. In the next video, we'll learn about animating the slide component by binding a gesture to the animation state. Welcome to a new video of the section. animating the slide component by binding a gesture to the animation state. In the previous video, we created a physics-based animation using Dynamics.js. In this video, we'll learn how to animate the slide component by binding a gesture to the animation state. The app we're going to create will have 3 slides, and we'll animate them on swipe of left or right. Another way to get a wow experience from users is to have great-looking introduction slides. A typical app would have 3 to 5 slides to describe what the app does and how it will benefit the users. Today, many apps even add videos or interactive screens so that users can get a feel for how the app may work. Such an interactive animation will require some internal development to bind touch gestures to the animation state. Animating based on a specific state is very difficult because you only really have to get granular gesture data. On the other hand, it's a lot easier to just animate at the beginning or ending of a state. For example, you could animate an object inside a slide when the slide completely shows up on the screen after a left swipe. However, this animation effect is not as interesting or attractive as binding the animation during the touch movement. The app we're going to create will look like this. You'll see the fade in and fade out animation effects between slides. This Angular 2 logo also moves up when you swipe left from the second slide. There's no need to test the app in a physical device because the animation is done via HTML and JavaScript. However, it's recommended to test the app in your device to evaluate animation performance. Let's get started. Create a new slider animation app using the blank template. Once done, go to the slider animation folder. Let's open the code in the code editor. So we can see that our app is opened in the VS Code. Now we need to open the source, pages, home.html file and modify its contents. At first, edit the name and replace the content of Ion content with the code seen on screen. And save the file. This template mainly uses the Ion slides tag. However, there are some layers to float on top of the Ion slide tag in order to animate them separately. After this, replace the content of home.ts file in the same folder. Here, you'd need to import viewChild and replace the content of homepage. Now note that here we are specifying the comments are useful to calculate an animation formula for each object. Next, we need to edit the home.scss file from the same folder. You need to add this code from the code bundle. Now go to your terminal and let's run the app. Awesome, you can see your app is running. Now swiftly slide the cursor to the left. We can see there are 3 slides here, so you can keep sliding them from left to right. Great! Now let's see how it works. This is the general process for animation. Since there are 3 slides, the user has to swipe twice to reach the end. This means that the first swipe will be at 50% progress. When the user swipes left to 25%, the Ionic logo will fade out. When a user swipes to 50%, the Angular logo will fade in for the second slide. When a user swipes to 75%, the Angular logo will move up to disappear instead of fading out. Finally, in the last 75% to 100%, the JavaScript logo will fade in. You must have probably noted the amount of fade or movement will depend on the progress percentage. Thus, if we swipe left and right a little bit, we can see the animation responding to the gesture right away. There are 2 layers in the template. The floating static layer must be on top, and it must stay at the same position regardless of which slide is current. Let's check this in the editor. So, this is our floating static layer. This must be on top, and it must stay at the same position regardless of which slide is current. Now the bottom layer is the typical Ion slides. As you can see, these are the Ion slides. When we swipe, it's actually moving from the Ion slide. However, it also triggers the onMove method because we bind it with the move event. So this is the onMove method. The onMove method will access slide float 1, slide float 2, and slide float 3 from the floating div layer. The home.ts file is where we have to animate these individual floating slides. There are several variables that we need to declare in the home.ts file. We need to be able to access the Ion slides object in order to call the native swiper methods. According to the Ionic documentation, the Ion slides object is written based on the swiper library in the Ionic framework website. Now we need to bind it with the swiping event natively in order to get the correct progress data. These 3 variables are necessary to access each floating slide. Also, we need to leverage request animation frame for the best animation performance. Otherwise, users will sense a jerky movement during a swipe because our animation is not at 60 frames per second. Lastly, we need to bind the swipe event only once. Thus, it's necessary to have a Boolean toggle to detect the binding event. This code shows us how to create a request animation frame object to call whichever function is to be rendered later. The onMove method is where we put all the animation logic, which must bind with the onProgress event. Now let's take a look at the code at the bottom of the onMove. As you can see, this is the line of code. Basically, we want to have 4 quarters or segments of animation. When we swipe from slide 1 to slide 2, it will trigger the first quarter and second quarter methods. That is, we want it to fade out the first floating slide and fade in the second floating slide at the end of the process. The concept is similar for the third quarter and fourth quarter methods. Note that we don't want to call the method directly, but just pass the function reference inside this.raf, so as to have the rendering engine manage the frame rate. Otherwise, the rendered function may end up blocking all other processes in the UI, which causes jerky movement. This is the first quarter. Now, for each of the quarters, we have to change the style property, which is given in the progress value. It's important to use the arrow function here so that we can access the this content. We have to call this SlideFloat2 native element to get the div DOM object. It's completely up to you to write your own math function to calculate the position or opacity during the slide movement with the progress value. Here, SlideFloat1 opacity variable is just a linear function based on the progress input value. The second quarter follows the same approach. As you can see, this is the second quarter. The third quarter uses the transform property instead of opacity. You can see the third quarter here, and this is the transform property. There are many ways to make a DOM object change its position. However, it's best to leverage the transform property instead of using the left and top properties. We want to achieve the highest frame per second. In the third quarter method, our slide float to transform will be calculated, and it will update a new Y position using translate Y. Now note that here we must use this bind on progress to disable another event binding to on progress, because for each swipe it will continue to add more events. As you can see, this is the fourth quarter, similar to the first and second. To understand more about Request Animation Frame, you can check out the official documentation at the developer Mozilla site. The Swiper API is located at idanger.us. Here you'll get to learn more about Swiper API. Ionic 2 has an official usage example at the Ionic framework site. Ionic 2 also provides a limited number of APIs for slides here. In this video, we animated the slide component by binding a gesture. In the next video, we'll learn to add a background CSS animation to the login page. Hi and welcome to the final video of this section on adding a CSS animation in the background of our login page. In the previous video, we learned how to animate the slide component by binding a gesture. In this video, we'll be showing some floating squares in the background of our login page and include some CSS animation to it. Animation can also be completely done in CSS. In many cases, you'll probably run into some interesting demos online and would like to incorporate the CSS-only code for animation. If the animation is not as critical to the user experience, you could just use to add additional effects to the app. CSS animation is great because you don't have to write JavaScript code to manage the animation, and just leave the browser to process it. This is how our app will look once we've included some animation. There is no need to test in a physical device because CSS animation will work just fine in the Ionic app. So let's get started. First, we'll need to create a new Bubble Login app using the blank template. Once done, you can go to Bubble Login and open it in the code editor. Here you have to open the home.html file and modify the content. First, we need to write here Bubble Login in the Ion title. You need to replace the content of the Ion content with this. The BG Bubbles class will convert a list of li into floating squares pieces. Now, let's edit the home.scss. The file looks quite big. As you can see, this is the line of code to be added in the file. Now let's go to the terminal and run our app. Awesome, it's working. We can see that the bubbles are in the form of square pieces. Let's type the username as hocfan and the password as hoc123. Here we've created only one page. You can create n number of pages such as this. Now let's see how this works. Since this app does not use JavaScript for animation, there's no need to modify anything in the home.ts file. Now let's go to the editor and understand the code. The CSS will drive the animation infinitely. For a 0% to a 100% loop, it will move 700 pixels vertically and rotate 600 degrees in the duration. The reason that each square has a different size and speed is because we can customize the CSS as per the li tag further, as seen here. Now, since this animation does not generate a random number of square objects and there are a limited number of objects, we could write a customization for each li tag in the CSS. Note that we have to put the animation with Z index 0 because it will stay above the other layers, such as form and button. To understand more about CSS keyframes, you can check out the Mozilla documentation at this site called developer.mozilla.org. You can learn more about keyframes here. In this video, we've learned about adding animation in the background of our login page. In this section, we saw a quick overview of animation features by embedding a full-screen inline video in the background, created a physics-based animation using Dynamic.js, animated the slide component by binding a gesture, and finally added a CSS animation to the background of a login page. Looks like we've come a long way, but there's still a lot more to learn. In the next section, we'll be learning about user authentication and push notification using Ionic Cloud. Hello and welcome to section 6 of this course on user authentication and push notification using Ionic Cloud. In this section, we'll learn about registering and authenticating users using the Ionic Cloud, building an iOS app to receive push notifications, and building an Android app to receive push notifications. Great, let's get started. We'll start with the first video on registering and authenticating users. In this video, you'll learn about registering and authenticating users using the Ionic Cloud. You'll learn how to register a new user, log in and logging out a user, and change user profile data using custom fields. Ionic Cloud can provide all of the user management and authentication capabilities out of the box. Providers supported by Ionic Cloud are email password, custom authentication, Facebook, Google, Twitter, Instagram, LinkedIn, and GitHub. Depending on the app, you may not need to use all of these authentication methods. For example, it would make more sense to use a LinkedIn authentication for an app focusing on a working professional to narrow down the audiences who are fit to use the profile of the app. If you have your own authentication server, where you maintain your own user database, you can still use the custom authentication of Ionic Cloud to create a custom token. This video will try to simplify the authentication concept as much as possible. You can run this app via a browser. There is no need to test the user authentication using a physical device. Create a new MySimpleAuth app using the blank template as shown, and go to the MySimpleAuth folder. You can now see the app being created. Great, now you can go to the MySimpleAuth folder through CD. Let's now open the app in the code editor. We do this by typing code space dot. Now the app is open in the VS Code editor. Now let's go to the command prompt again and install the Ionic Cloud Angular. So install npm. Install at the rate ionic/cloud-angular-save. So you can see the Ionic Cloud is being installed. Once it is done, then you can initialize the Ionic Cloud settings so that an app ID can be created in your account. So for that, you need to execute this line of code. Ionic IO init. Great, it's done. You'll be prompted to log into your Ionic Cloud account for this command line. The initialization process will save the app_ID and API_key values to your project's Ionic, io.bundle.min.js. This means that you cannot change the project in your Ionic Cloud account after this, or you'll have to manually remove the IDs and reinitialize. Your app ID is also recorded in the ionic.config.json file. So, we need to log into the Ionic Cloud. Don't worry though, if you don't have an Ionic Cloud account, you can log into this site called ionic.apps.io, sign up on this site, create the MySimpleAuth project. To do this, just click on MySimpleAuth. You can see the ID here, just copy it. Now let's go to the code editor. In the terminal, you need to fill your email ID that you registered with and your password. Great, let's finally go to the code editor. Now you need to open the app.ts.module file, so let's go to the source, app.module.ts file. Here you need to include an import. Write import cloud settings and cloud module from Ionic/Cloud Angular. You need to include this in these single quotes. Once this is done, you need to add your app ID in the core module, so enter and type this and paste your ID here in single quotes. So this is the line of code you need to add in your app.module.ts file. Next, we need to import the cloud settings for the root. So here, you need to add this cloud module dot for root cloud settings. This is the line of code you need to add. After that, you just need to delete this since it is no provider. We've added the import and this cloud setting part and the imports for the cloud for root, so now you need to ensure the app ID has the correct value for your case. So now let's edit the home.html in the sources page folder. Great, let's go there. Here in the header you need to write as user authentication and replace the Ion content. These are just basic login and logout pages all in a single page for added simplicity. So this is the home.ts file. Now here you need to add this line of code and imports in the home.ts file. Here in this code we created 4 methods: register, login, save, logout. Now finally add a minor input field alignment in home.css. In this page you need to add this line of code and save the file. Now go to the terminal and run the app. Type Ionic serve. So you can see the user authentication page with user and password. You can type an email, user1@test.com, and password as user123, and click on register. Once you do this, it starts registering and save. And it asks for the user profile, so you can type a name, say HockFan, and a birthday, say 1, and click save. The profile was saved successfully. You can log out and log in once again. Just type in user1@test.com and password user123 and log in. It will take you directly to the page and display your details. In a nutshell, Ionic Cloud acts as a back-end server for your app. It allows you to create a new user record in its database. Through the user class, you can interact with the Ionic Cloud authentication system. The first step is to register the user. This takes an email and password as shown on the screen. When you click on register, this is the code that executes. The details object has the email and password from the form. Once it is successfully completed, it will automatically log in the user via this .auth.login. Note that this piece of code here is just to show the loading screen to prevent the user from clicking on the register button multiple times. This example app only has a name and birthday as custom user data, as you can see on the app. To save the user profile, you can call the save method as shown in the following code, as you can see here. If you look into the console log, the user token and custom data are also available. Now let's go to the app and see the console. Here the custom data and the user token is also available. You can also view the user data in the Ionic Cloud portal. Log into your account and navigate to the app's auth menu. Click on the View button of the user you created. There is only one user, so the data is already displayed. Select the Custom Data tab and you can see the same information stored for the user. For more information about user authentication, you may want to refer to the official Ionic documentation at docs.ionic.io. Great! So in this video we saw how to register and authenticate users in the Ionic Cloud. In the next video, we'll build an iOS app to receive push notifications. See you there. Hello and welcome to the second video of this section, building an iOS app to receive push notifications. In the previous video, we registered and authenticated users using the Ionic Cloud. In this video, you'll learn how to set up Ionic Cloud for iOS push notification, configure the iOS app, certificates, app and push, and provisioning profile and write code to receive push notifications. Push notification is an important feature to engage users frequently, especially when the users are not using the app. Many people download an app but only open it a few times. If you send them a push notification message, it will encourage them to open the app to get involved in a new activity. Implementing push notifications is very complex if you have to build everything from scratch. However, Ionic makes it very simple by leveraging the Cordova push notification plugin and Ionic Cloud as the providers. A push notification provider is a server that can communicate with the Apple Push Notification Service, APNS, or Google's Firebase Cloud Messaging, FCM. You can set up your own provider's server using existing open sources, but you have to maintain this server separately and keep up with potential changes from the APN APIs. Here is how our app will look after receiving a couple of notification messages. It's required to have a physical iOS device available in order to test for message notifications. You must also register for the Apple Developer Program, ADP, in order to access developer.apple.com and iTunesConnect.apple.com, because these websites will require an approved account. In addition, the instructions on the screen use a specific version of these components. Now let's see how to do it. First, we'll create a new My iOS Push app using the blank template and Angular 2. This will take a few minutes because Ionic needs time to pull the blank template and all the modules necessary for the template. Now we'll go to the folder. We'll install the Ionic Cloud-Angular client, which is a library to interact with the push object. You need to have Node version 4.x or later and NPM version 3.x or later. Then you have to initialize your Ionic Cloud setting so that an app ID can be created in your account. You'll be prompted to log in to your Ionic Cloud account for this command line. The initialization process will save the app_ID and API_key values to your project's ionic.io.bundle.min.js. This means you cannot change the project in your Ionic Cloud account after this, or you'll have to manually remove the IDs and reinitialize. Your app ID is also recorded in the ionic.config.json file. Next, you need to install the Cordova Push Notification plugin and provide some value as sender_ID. Since you're only using iOS push notification, you can just provide a fake value, temporarily, here as shown. The name of the plugin is PhoneGap-plugin-push. Type code space dot to open Visual Code. You can see in ionic.config.json, this is your app ID in Ionic Cloud. I'll just change these screen settings so the font is clear. Here, it looks good now. Now let's open the module.ts. So we'll modify the header here. You don't need the error handler. You need to have the cloud settings and cloud module from Ionic Cloud Angular module you installed earlier. Then you also need to declare constant cloud settings. Now we need to place the app ID and push notification settings that you need to have for iOS and Android. In your ng module, you need to make sure that you have homepage and my apps in your declarations. Then you need to enter one line, the cloud module, and declare the cloud settings as the parameters. You can remove the error handler provider here. Now we'll visit the Apple Developer website and click on Certificates, Identifiers and Profiles. Make sure you select the correct device platform you're targeting. In this case it will be iOS, tvOS and watchOS. Then navigate to Identifiers, App IDs. Here you can add the app ID from your Ionic app. Click on the plus button in the top right corner of the screen. Give it a name first. You can use the same name as the project. In the bundle ID, we're going to use the bundle ID from config.xml. So let's go to our terminal, go to the app, open the config.xml, and this should be your bundle ID. To enable push notifications, you need to check the push notification service. Click Continue. Select Register. Select Done to complete the steps to create App ID. Now you need to request a certificate from your Keychain Access on macOS. Navigate to the Keychain Access app, top left menu, and navigate to Certificate Assistant. Request a certificate from a certificate authority. Enter your user, email address, and common name. Check Save to Disk. Click on Continue. My Certificates. Then click Done. Navigate to the Apple Developer website and navigate to Certificates. All. We need to add the certificates. In this example, you'll select the development version instead of production. Click on the Continue button to proceed. And you can now create a CSR file. Click on the Choose File button to upload your signing request file that you created earlier in your certificates folder. Click on Continue. And now you have to download your iOS developer certificate again. Click on the .cer file you downloaded, as shown, so that it can be imported into Keychain Access. Locate your certificate in Keychain Access because you need to export this to the .p12 file format. Ionic Cloud will need this file later in order to generate a push token and send push notifications to the app. Right-click on the certificate and select Export from the drop-down menu. Save it in the same folder as My Certificates. Make sure you provide a password to protect this file. You must provide a password in this step, although it's optional in Keychain Access. The reason is that Ionic Cloud cannot import a P12 file without a password. Sometimes it asks for your Keychain Access. It is the password you set on your computer, so let's go ahead and do that. Now let's go to the website again. We're going to go to Devices, All. If you don't have your iOS device listed here, you may want to add it. Click on the plus button. Give it a name and provide the device UDID and save to register the device. Since we already have the device registered here, we aren't going to do that again. Next, we're going to create a provision profile. Navigate to Provisioning Profiles, All. We'll click on the plus button. Select iOS App Development. Click Continue. Select the correct app ID in the drop-down menu and click Continue. This is for the certificates, so select all certificates. This screen is for devices. Here I'll select all the devices too. Click on the Continue button. Provide a profile name to your provisioning profile. Click Continue and download the provisioning profile file in the same folder. Click on My iOS push_provisioning_profile.mobile provision, which you just downloaded, in order to import it into Xcode. This step is very important because if you don't import it into Xcode, your app cannot be built successfully. If your app failed to build because of an invalid provisioning profile, it's best to check the provisioning profile status in the developer console. You need to enable the push notification feature. For that, you must request a push certificate, which is different from the app certificate. So, let's go back to the Apple ID you created earlier, that is My iOS Push. We'll edit this. Go down to the Push Notifications section. The push notifications must show the configurable state, otherwise your app is not available for push notifications. Click on the Create Certificates. Here, you'll be taken to a new page to create your CSR file. Click on the Continue button here, and click on Choose File. Locate the certificate signingrequest.cert signing request file you created earlier. Select that, click Open. Click on Continue again. Now your push certificate is ready, so go ahead and download that. Once your .cer file is downloaded, you need to click on it to import it to Keychain Access. Locate the new Push Services certificate in Keychain Access and select it. Right-click on the certificate and select Export. Give it a new name to avoid overwriting it to the app certificate. We're going to call it push_certificates.p12. This process is basically converting a .cer to a .p12 for Ionic Cloud. Provide a password for this .p12 file to protect it. A password for the P12 file is required because Ionic Cloud will not import a P12 file for the APM without a password. Click OK here and done. Let's go back to the browser to go to Ionic Cloud website. Here is your Ionic project already generated. Navigate to Settings page, go to Certificates, and click on New Security Profile. Provide a profile name. I will call it My Push Profile here. Right, now let's keep it in development. When you are ready, you can select Production and click on the Create button to save the profile. Now, let's get back to the profile. Click on Edit. You'll need to upload 3 files: a provisioning profile, an app development certificate for the app itself, and an APN certificate for push notification. Click on Choose File under Push Notification Service and upload the push_certificates.p12 file. Click on Choose File under Build Credentials and upload 2 files: certificates.p12 for App Store Certificate and My iOS Push Provisioning Profile.mobile provision for the provision profile. Ensure that you provide the same password that you provided earlier. You should not get confused between the 2 P12 files, that is one for your app and one is for your push notification feature. Click on Save to save your security profile. And that's it. This completes your Ionic Cloud setup for push notification. So let's go to the next step to modify the homepage code in order to receive notification messages. So you need to modify your homepage, including home.html, home.scss, and the home.ts files. First, let's go to the home.html. We're going to do a minor change in the header. Let's call it push notification. In the Ion content, we are going to delete everything here. Most importantly, you need to have 2 things here: the code class so that you can put the push notification text in here. Push token is the variable name. Now I'm going to add the buttons. This is the template for the home page. Now I'm going to go ahead and paste the existing code that I have. So this is the button code. The register push is our button, and when you click on it, it will go to registering. When you have no push notification, it would show no message. And when you do have a push notification, it would show your messages. And it would display a list of messages in Ion Card. Now let's go to the TypeScripts file. We need to import a few things. Here you have the component by default. You'll need the application reference, and then you need to import the push tokens from Ionic Cloud Angular. I'm going to keep the component's definition the same, but in here we're going to change a few things. So in the home page, you define the push tokens and the messages array. You change the constructor. You have private messages for the process push. And register push is something you declared in the home.html here. Click register push. Next, we're going to modify the style sheet home.scss with this. These are really minor changes regarding how the app will look. I have a big square here to render the text in the middle of the screen. Subtitle, Ion Card header. That's about it. Let's save this and we're ready to run the app. First, connect your physical Apple phone to the Mac. I've got an app on the right side here. Then we're going to run Ionic iOS -- device. This command will basically build the app for you, package it up, and then push it to the device connected to your USB port. The OS will prompt to allow code design to sign using the iOS Developer Certificate. You must accept this to allow access in order to build the app and upload it to your device. It's going to take a few minutes for the build to complete, and it looks like it has been successfully built. Now it's pushing the app into the iPhone. So you can see here on the right side, the app is now shown on the iPhone. Let's turn on the app developer so that we can inspect the output in the console. The next step is that you have to click on the register push button to acquire a token. As you can see here, the token has been successfully received. Let's go back to Ionic Cloud. Go to your app, My iOS Push, then the Push tab, and click on the Create Your First Push button. Give it a name. Click Continue. Select All Users. Click Continue again. Select the security profile we created earlier, and we send it now. So you can see here on the right side the push notifications show up, And on the console you can see under push message the message and the title. So this means your push notification application has been successfully completed. To understand how the entire process works, let's summarize what you've done. Now first take a look at app.module.ts. And we see that the import has to declare cloud settings and cloud module. Also, the app ID has to match. In the push notification you have sender ID, then for iOS you have the badge and sound. The value depends on if you want to disable or enable them. Push provider. Now let's focus on the coding portion itself to understand how this works. You need to change how the app bootstraps in app.module.ts. This requires the importing of provide cloud and cloud settings providers as shown. Besides setting the app_ID to match with your project app_ID in Ionic Cloud, you need to specify the push object with the parameters you want for both iOS and Android. Then, inside ng module, you need to insert the so that Ionic knows that it needs to initialize Ionic Cloud as well. In your home.html template, there is a button to trigger the registration of push notification by calling register push. This registration process must be intervened manually by the user because the user will have to accept permission in the next step. It's not recommended to require the users to accept a push notification request when they open the app right away. The main reason is because they're not familiar with your app and don't know what to expect this is, whether they will get bombarded with notifications later on. The messages will be displayed via the messages object. Here, each message item has the title and text fields. In home.ts, there are two critical imports that you must be aware of. Push and push token are required to register and receive push notifications. Application ref will be discussed later, as you need to trigger re-render the Angular template manually. All you need to call is the this.push.register function. This will return a push token object in console log. To receive notifications, you need to subscribe by using the following code: this.push.rxnotification.subscribe. This will call process push each time there is a new notification message. When the user receives a push message, this function will append to the messages array. If you don't call this.applicationRef.tick, the UI will not get updated since this process is outside Angular cycle. Ionic has its own iOS setup instruction pages at docs.ionic.io. The Cordova push notification plugin is available directly at github.com. For more information about the Apple push notification service, you can visit the official documentation at developer.apple.com. Great, so this is it for this video. In this video, we built an iOS app to receive push notifications. In the next video, we'll build an Android app to receive push notifications. See you there. Welcome to a new video, building an Android app to receive push notifications. In the previous video, we built an iOS app to receive push notifications. In this video, you'll learn how to set up Ionic Cloud for Android push notification, configure the Firebase project for the Push API, and write code to receive push notifications in Android. Push notifications work in the same way as iOS for Google. However, instead of using the Apple notification service, you'll be working through the Firebase Cloud Messaging Server, which is a new replacement for Google Cloud Messaging, GCM. However, Ionic Cloud abstracts this process so that you don't have to code using a different API. You'll be using the same push object as for the iOS app. For more information about the differences between FCM and GCM, visit the FAQ at firebase.google.com. You'll be using the same code as your iOS push notification example. The main difference is the process to set up in your Firebase and Ionic Cloud account. You can test the Android push notification using the Android emulator, so there is no need to have a physical Android device available. You must also register for Firebase in order to access console.firebase.google.com. You need to sign in with your account. In addition, you need these components. You'll also need Android Studio 2.x with at least Android 5.1 Lollipop installed. You need to go to Android Studio, Preferences. You can go to Android SDK under System Settings and check these platforms. Click on Apply, then OK. You also need Android SDK tools, Build Tools, Platform Tools, and Intel Hardware Accelerated Execution Manager, HAXM. You'll find the installation steps here. You can just click on Launch Standalone SDK Manager and you can install all the tools from here. Next, you need at least one Android virtual device. So go to the terminal and type the command. You can see that at least one Android virtual device, AVD, is created here on which we can deploy our app. Let's create the app. You can just make a directory and go to that. Now let's create a new My Android Push app using the Ionic start command. As usual, it takes time. Change your directory to the folder My App Push. We need to install the Ionic Cloud Angular client, which is a library, to interact with the push object. Here is the command line for that. You need to have Node version 4.x or later, and NPM version 3.x or later. Let's initialize your Ionic Cloud settings so that an app ID can be created in your account. You'll be prompted to log in to your Ionic Cloud account for the command line. So, provide your app ID and password. Now type ionic.io. So, you can see an app ID is created in your account. You'll need a Firebase project number and a Firebase server ID in order to set up your app.ts file correctly. First, let's log into the Firebase console at console.firebase.google.com. Click on the Create New Project button and fill in the project name, that is My Android Push. Select the country. Now, in your app, go to Navigations in the left navigation menu. Select the Android icon. The Firebase Cloud Messaging Service also supports the iOS app, so it's possible that you can use FCM for both iOS and Android projects. We'll provide package name in that form. You can copy and paste the package name from your app project at config.xml. Let's go to the terminal and open our Visual Studio. When we go to the config.xml, you can see your app ID here. You need to copy and paste this app ID and paste here. Just click on Add App. Select Continue and save the JSON file somewhere. You will not need this JSON file for the Ionic project. Click on the Finish button to complete setting up the notification service. Now you'll need the server key and sender ID. Navigate to the gear icon in the top left corner and select the Project Settings menu item. Select the Cloud Messaging tab. Copy both the server key and sender ID, the same as project ID if using Google Cloud Messaging. Navigate back to the terminal and ensure that you are in the Ionic project folder. You need to install the Cordova push notification plugin and provide the same sender ID value as the sender_ID value in the command line previously. So type this command. In this, the sender ID will be pasted that we generated. Now let's go to VS Code. You need to open the ionic.config.json file. You need to copy the app ID here. Next, open app.module.ts file. We need to edit this file. We'll import cloud settings and cloud module from Ionic Cloud Angular. Add this code in the file. You must replace app_ID with your own app ID. Also, you have to provide sender ID here one more time. The code for your homepage is very similar to the iOS push example. Next, replace the content of the home.ts file in the same folder with the code highlighted. Import the token from Ionic Angular. Add component home.html. Add the code for the homepage here. Next, we need to replace home.scs also in the home folder. If this is the first time you create the app, you must have a key store file. This file is used to identify your app for push and publishing. If you lose it, you cannot update your app later on. To create a key store, let's go to the terminal. Type this command line and ensure that it's the same keytool version of the SDK. That is, check your path environment variable. Enter the key store password. You need to enter your first name and last name, organisation, city or locality, and state. Type yes here. Good, our key store is created here. You must provide a password for this step, otherwise Ionic Cloud won't let you upload the key store file. Now log into your Ionic Cloud at apps.ionic.io to configure the security profile next. Navigate to your project, that is My Android Push, and select the Settings menu. Select Certificates. Create a new security profile and provide a name, for example My Android Push. Click on Create. So you can see that the security profile and credentials here. Select Edit and Android. Let's upload your key store file, so choose File. Our key store file is generated here in the My Android Push app. Open it and enter the password that we had given earlier. Also, enter the alias name. Paste the server key from Firebase into the GCM API key input box. Select Save to complete creating a security profile. Now navigate back to the terminal. Ensure that you're in the App folder and build for the Android platform. Type Ionic Emulate Android. If you need to add Android platform to the project to run the app on Android, type Ionic Platform Add Android first. You can see that it will launch the emulator. The process to verify push notification for Android is very similar to iOS. For that, navigate to Ionic Cloud. Your app, My Android Push, then go to Push. Click on the Create Your First Push button. Name it as Test 1 and click Continue. Leave the segment as All Users so that anyone can get the push. Select your security profile, that is My Android Push, that you created earlier. Then click on the Send This Push button. Verify that the push notification has been sent successfully from Ionic Cloud. It should have the sent status here. In the app on your simulator device, click on the Register Push and you'll see our message. You successfully completed the verification steps. At a high level, this is the communication process behind the scenes. Your device sends a registration request for push notification to Google's Firebase server. Your device's app must have Firebase Project ID, Firebase Sender ID. So Google will reply with the registration ID, which is the same as the push token from the Ionic Push object. Your app will send the registration ID to Ionic Cloud or any push provider server. This process is behind the scenes because Ionic Cloud Angular calls Ionic Cloud APIs to execute. However, your Ionic Cloud must have a security profile with 4 pieces of information that are Firebase's server key, key store alias, key store password. Ionic Cloud will save this registration ID to request Google to send push notifications later. You can trigger notifications via the Ionic Cloud UI. This is very similar to how Ionic Cloud works with Apple. Everything is simplified into your interactions with the push object from the Ionic Cloud Angular module. To receive the console output, you can navigate to Google's URL at Chrome inspect/devices. This will provide a list of the available simulators to debug. Click on the Inspect link to open the Google Developer Tool. You should be able to see this screen. The app outputs a token, that is a registration ID, and each push notification will be a push message object. You can open and inspect the properties. In summary, Android push notification works nicely because of the out-of-the-box integration between Ionic Cloud, Ionic Angular module, and Firebase Cloud Messaging. Ionic has its own Android setup instructions pages at docs.ionic.io. On this page you'll learn about Setup, App Key Store, and Push and Cordova plugins. For more information about the Firebase notification service, you can visit the official documentation at firebase.google.com. In this video, we've successfully built an Android app to receive push notifications. Let's summarize the section. We started with registering and authenticating users using Ionic Cloud. Then we built iOS and Android apps to receive push notifications. In the next section, we'll learn about supporting device functionalities using Ionic Native. See you there. Hello, welcome to a brand new section of Ionic, supporting device functionalities using Ionic Native. This section will comprise of taking a photo using the camera plugin, sharing content using the social sharing plugin, displaying a term of service using in-app browser, and finally creating a taxi app using the Google Maps plugin and geocode support. Let's start with the first video of the section, taking a photo using the camera plugin. In this video, we'll first access the Cordova camera plugin to trigger camera capture and get the image in base64 or URI format. We'll then pass the base64 data or URI on an IMG DOM object and display the URI if it's in the URI format. Next, we'll capture an event of a toggle component and finally display long data using horizontal scroll. In this section, you'll learn how to access some common features of a device, such as the camera, contact list, email, and maps. Some of these features can be written in a JavaScript-only environment, but the performance is not on par with native support. Cordova has a very well-supported community with many plugins. You may want to check out plugins.cordova.io to understand what is out there. Luckily, you don't need to deal with these plugins directly. You'll use the Ionic Native service on top of Cordova and Angular 2. You have to use the Ionic Native instead of NG Cordova for Ionic 2 because of compatibility issues. You can only use NG Cordova for Ionic 1.x. For this video, you'll make an app to take a picture using the device camera or load an existing picture from the device album. The picture could either be in base64 format or saved in a local file system relating to your app. This is how your app will look in the end. You should have a physical device ready in order to test the camera capability. It's possible to just run the code via an emulator, but the file system support might look different across the various platforms. Let's get started. First, we'll start a blank project, for example, My Camera, so use the Ionic start command for that. It will take some time for the downloading and installing of components. Once it's done, we have to go into that folder. Next, we'll add the Cordova camera plugin using this command. You no longer need to add NG Cordova separately. Also, you should not use the Cordova add command line directly. Instead, use the Ionic plugin add. You should be able to see a new folder, org.apache.cordova.camera, being added in the plugins folder. Then we'll add it home.html file in the source, pages, home folder. This is the code you'll add in the Ion content. Since you only have one page, this template will show two buttons and an area to display the image. We'll then modify the home.ts file. The imports, the component tab, and the home page should be seen as on the screen. There is only one method, getPicture. This method will return the photo data so that the template can render. Now that that's done, we'll replace home.scss with our code here. There are only a few minor changes in the styling so that you can keep them simple. Now, connect your device to your computer. For that, you have to go to your terminal. Execute the command line for iOS. Ionic run iOS. If you're not able to push the app to your physical device using the preceding command line, you can use the Ionic run iOS -- device to specify the CLI to use the physical device instead of a simulator. If you want to run the app in your Android device, use the command Ionic run Android. So you can see that the app is not an Android project, so we need to add the Android platform. So type this command: Ionic platform add Android. Now you can run your app using Ionic run command. When you run the app, you should see the app as shown here. The app is being launched. There are two buttons here, Show Camera and Show Album. If you click on Show Camera, click the picture. Now look at the code in detail. Get.CameraPicture is just an abstraction of navigator.camera.getPicture from the Cordova camera plugin. If you're already familiar with Cordova or NG Cordova from Ionic 1, this should be very familiar. Let's start from the template. You have two buttons which trigger the same getPicture method. These are just different ways to access photos, either from the camera itself or from the existing photos in the phone's album. For the photo to render, you need to pass the photo data into the source attribute. Note that you only want to show this image tag when image data exists with some data. The image data variable could be base64 or an internal URL of the photo. To specify this option, there's a toggle button here. You'll use the useURI variable inside the class as illustrated to determine which format to return the photo data in. Both useURI and source type will be used in the getPicture function. It's important to adjust the quality target width and target height to low so that the photo is not too big, which could crash the device, especially when it doesn't have enough memory. When you return the base64 data, it must be prefixed with the string data:image/jpeg::base64. One item that isn't discussed here is the ability to post image data to the server. The common scenario is to upload the file from the file system. It's not a good idea to send data as base64 because of the data size, which is double the original binary size. It's possible to create Instagram-like filter effects using just JavaScript. You can leverage an existing library such as Filterus to modify the image canvas directly. There is an Instagram plugin for Cordova on GitHub. You could write some extra code to pass the image to Instagram. The user must have Instagram installed on the phone first though. This idea is nice when you plan to do some cool image processing, for example adding funny text before letting Instagram perform the photo filter operation. You could even add Cordova's social network plugin and post the resulting images to Twitter or Facebook. In this video we took a photo using the camera plugin. In the next video we'll be sharing content using the social sharing plugin. Welcome back. This is the second video of the section, sharing content using the social sharing plugin. Previously, we learned how to take a photo using the camera plugin. In this video, we'll first create a social sharing template. Then we'll add the Cordova camera plugin. Lastly, we'll import the module into Ionic and run it. If you develop an app with shareable content, you might want to utilize the native device feature to share via the device's authorized social media accounts. There are several benefits from using this approach. First, users don't need to open a separate browser to log into their social media account each time they want to share. Second, all the information can be filled out programmatically, such as title, body, link or image. Finally, since this is a native feature of the device, the menu selection allows users to see multiple accounts, which they are already familiar with, to choose from. The social sharing plugin can greatly enhance the user experience. You can see the app that we're going to build. When the user clicks on the Share button, the app will show the native menu for social sharing account selection. If the user selects Twitter, a pop-up will show with all the information pre-filled. After posting on Twitter, the user goes right back to the app without ever leaving it. You should have a physical device or simulator ready in order to test the social sharing capability. First, start a blank project. For example, link social share. Once the project is created, go to its folder. Then we need to add the Cordova camera plugin with this command line. When it's done, open home.html and replace its contents with the code shown here. This is a very simple page with the card element. The like button is just there for cosmetic reasons without code implementation. However, all the JavaScript logic will focus on the share button. So let's edit the home.ts file where the share button details are to be entered. You need to import social sharing from Ionic Native. Add this code after the nav controller. You can see in Platform that it's an iOS app and not Android, so we need to add the Android plugin. So go to a terminal and type this command: Ionic platform add Android. If you have an iOS device, you can run using Ionic Run iOS. For an Android device, use Ionic Run Android. The emulator is being started and the app is launched. You can see this small share button here. When I click on it, I'll get this box. Then I click New Message. Since I have linked the message option here, it will take me to my Messenger app. Here I'll input the person I have to send it to and the message. Once it's done, it will go directly to the API. You can start looking at the template because that is where the social media content is extracted from. The subject value is from the hash message subject local variable as shown. In this case, the subject is Ionic Developer because you'll access the message subject.inner text later on. Message subject is just referencing your H2 DOM node. Similarly, the body is from message body as shown. When the user clicks on the share button, it will trigger the send share method. Let's take a look at your home.ts to understand how send share works. First, we've imported the social sharing module from Ionic Native. Ionic 2 makes it very convenient because you don't need to install ng Cordova separately. Ionic Native is actually a default option that comes with the project during its creation. To share your content and trigger the social media menu, the logic as shown is very simple. If you want to share a file, you can replace the third parameter, where it's null, with the URL to the user's local file system. This is useful when you want people to send a PDF or JPEG via email or post it on Facebook. To see the latest update of the Social Share plugin, you can visit the documentation at ionicframework.com. In this video, we shared content using the Social Sharing plugin. In the next video, we'll be displaying a term of service using in-app browser. Looking forward to it. Hi, this is the third video of the section, displaying a term of service using in-app browser. In the previous video, we learned to share content using a sharing module. In this video, we'll first install the in-app browser plugin. We'll then create a project and make the changes in different files. We'll finally run the app. In many apps, you sometimes require users to accept a term of service before they can move on to the next page. The typical approach is to create a pop-up model or a new page showing the term of service. Once users finish reading, they can click on the Done or Back button. However, if your content of your term of service changes, you may need to ask users to update the app. In many cases, users don't update apps often, so the terms of service they accepted could be older than your current version. Therefore, there is a need to maintain term of service content separately from the app itself. The in-app browser plugin is the best solution for this because you can point users to the same term of service page that is already on your website. The app will just have a simple checkbox and a button to demonstrate how in-app browser works. The app will look like this. Once the user clicks on the Please agree to our terms checkbox, they'll go to the in-app browser page as seen. After going through the term of service content, they can click on Done and go back to the previous page with the Next button enabled. You should have a physical device ready in order to test in-app browser, as this won't work in the browser as an iframe. You can also use a simulator. Let's start with creating a blank Ionic app, for example online TOS using the Ionic Start. As usual, it will take time. Once it's done, open the project in Code Editor using code space dot. Then open config.xml in the project folder and insert 2 lines under Access Origin as you can see on your screen. This will tell Cordova that it's okay to allow navigation to any website. Otherwise, the device security will block in-app browser. You can read more about this on the Cordova documentation page at this link. Open home.html file and edit its contents. You need to change the title and add this code here. Next, you need to open the home.ts file. Add import here. You also need to import platform from Ionic Angular. Then add code in the homepage. Open home.scss and replace with the contents with the code shown. This is just to provide minor styling to the page. As you can see, Android platform is not listed under the platform folder, so we need to run this line of code to do that. Go to the terminal and type Cordova platform add Android. Once it's done, you can run your app. If you want to run the app on an iOS device, type Ionic run iOS. As I'm using Android Simulator, I'll type Ionic run Android. Your simulator will start. You can see that there's a checkbox. If we click here, it takes us to the ionic.io TOS site, where all the services are listed. So, we've successfully created the app. First, let's take a look at the template home.html. There are two areas that you should make a note on. When the ion-checkbox component is clicked on, it will trigger the OpenTOS method, which will open the URL via in-app browser. The next button is disabled by default via the readTOS variable. So when the user checks the checkbox, this readTOS will be true and the button will be enabled. In our home.ts, we have imported the in-app browser module first, as shown. This makes the in-app browser object available for use in our class. Here is the OpenTOS method. You have to wrap everything inside platform.ready, because sometimes Cordova plugins load more slowly than the app itself, and it will cause an error if the user clicks on the button too fast to trigger in-app browser. To trigger in-app browser, you just need to call inappbrowser.open and pass the following three parameters. 1. The URL to load. 2. The target to open the URL. There are four options only: self, blank, and system. Self will overwrite your current Ionic app, thus you should never need to use this option. Blank is typically what you want because it leaves you a way to come back to your app. Finally, system opens a separate browser outside the app. 3. Options is the last parameter where you have to pass a string. You can visit the official document for more information at github.com. In general, you just need to set location equals true so that the user can see the current URL. Android and iOS have different options, so you should check the GitHub page to compare the different platforms. In-app browser also has an exit event where you can listen via ref.on. This is useful when you want to pop up a thank you dialog or record an event via the REST API to your server. To stay up to date with the latest changes in in-app browser, you can visit this link. Official support for the Ionic Native's in-app browser is located at ionicframework.com. In this video, we displayed service terms using in-app browser. In the next video, we'll create a taxi app using the Google Maps plugin and geocode support. Welcome to the last video of the section, creating a taxi app using the Google Maps plugin and geocode support. Previously, we displayed a term of service using in-app browser. In this video, we'll install the Map Google Map plugin. We'll create the Pick Me Up project and then get our location on our device. Today, many mobile apps utilize different mapping features, such as showing the current location, creating routes and providing suggestive business searches. This section will show you how to use Ionic Native's Google Maps plugin to provide mapping support. You'll create a taxi app that can display Google Maps in full screen, add a button overlay on top of the map, detect the current device location, and add a marker with any text. This is the final look of the app. When users click on the Pick Me Up button, it will go to the current device location and show the longitude and latitude information. It is possible to use HTML5 and JavaScript version of geolocation and maps instead of the Cordova's plugin. However, you'll see a negative impact on performance. It's very obvious that if you use the SDK, map rendering and optimization tends to be faster. In addition, HTML5 geolocation sometimes has some strange bugs that require the user to accept permissions twice, once for the app and once for the inside browser object. The Google Maps plugin requires a Google Maps API key for your project. You need a Google account and log in to get started. You can log in at this site with your Google account. Create a project if you don't have one yet. Just fill in the required fields. That is your project name and click on Create. You need to enable the Google Maps SDK for iOS, the Google Maps Android API, or both. It depends on how many platforms you plan to support. Let's select Google Maps SDK for iOS for this example. Then click on the Enable API button. Next, we go to Credentials to create our own key. Click on the Create Credential or API Key option. You can see your API key here. Fill in your app's bundle ID. Select the Restriction option. Then select the iOS app or Android app, whichever you're using. Fill in your app's bundle ID. You might not know exactly what it is yet because Ionic will create a random ID. So just put in com.ionicframework.starter and change that later. Click on the Save button. Now you should see the key for the iOS Applications section. Copy the API key so that you can use it to add the Cordova Google Maps plugin. Let's start an Ionic project from scratch and add the Google Maps features. For that, we'll go to the terminal and type this command. Create a blank Ionic project as shown and go to that folder. First, we have to replace the iOS platform with version 3.9.0. First, we have to remove the iOS platform from our app. So this is the command for that. Then we add iOS 3.9.0. Then we also need to add the Android platform. You have to pick iOS at 3.9.0 specifically because the current version of the Cordova Maps plugin only works with this version. Otherwise your build will fail. You should experiment with the newest version if possible. After that, we'll install the Google Maps plugin with your copied key. So, type this command. Replace the word key with our key that we generated earlier. If you do this for both iOS and Android, you need to add the key for both. You have to use the Cordova CLI here because the Ionic CLI to add Google Maps with the API key will not work. Open home.html to modify your template as shown. The main element here is your div with map ID, because that's where you'd have to inject the Google Maps object. Next, we'll edit our home.ts in the same folder. You need to import these classes. The home page needs to be modified. We're also creating two functions that are showMap and getMyLocation. Finally, make some minor adjustments to the style sheet so that the app can take over the full screen. Then edit home.scss as illustrated. Save the file. Run the app in the terminal with the command line. Depending on the platform, you can select your command. For iOS, it will be run iOS-device. Make sure device is connected to your Mac before running this command. For Android, it's Ionic run Android. As I'm using the Android emulator, I will use the second command. The app is being built. The Android emulator is being started, and then the app launches. You can see the Google map here. Once you click on the Pick Me Up button, it will show you the location. The core of this app is mainly in the JavaScript code, home.ts. In order to use the plugin object, you should declare it on top as shown. While it might seem that there are a lot of moving parts, the basic flow is very simple. We'll look at this now. Whenever Ionic and Cordova are ready, the trigger platform.ready.then to initialize the map by calling showMap in the constructor of the home page. When a user clicks on the button, the app will call getMyLocation to get the location data. The data will be used to create the marker and move the map's camera to center on that location. It's important to know that plugin.google.maps.map.getMap does take some time to process, and it will trigger a ready event once it has successfully created the map. That's why you need to add an event listener for plugin.google.maps.event.map_ready. This example does not do anything right after the map is ready, but later you could add some more processing functions such as jumping to the current location automatically, or adding more markers on top of the map. When the user clicks on the Pick Me Up button, it will trigger the Get My Location method. The location object returned will contain the latitude, location.lat.lng.lat, and longitude, location.lat.lng.lng. To move the camera anywhere, just call map.moveCamera by passing the location coordinate, location.latlong. To add a marker, call map.addMarker with the position and title as HTML. The Cordova Google Maps plugin has many more features, such as showing an info window, adding a marker with multiple lines, modifying icons, text styling, base64 encoded icons, clicking on a marker, clicking on an info window, creating a draggable marker, dragging events, creating a flat marker. Since you cannot pop up a div on top of native Google Maps, the marker features are very handy. Some additional scenarios are touch a marker and go to a page. You just need to listen to the plugin.google.maps.event.marker_click event and do whatever is needed in the callback function. Show an avatar profile image as marker. The add marker does take the base64 image string, thus you can pass something like this in the argument title, canvas.toData_URL. Note that Google has a quota on free API usage. For example, you cannot exceed 1 request per second per use, and you can only have a couple of thousand requests per day. This quota changes all the time, but it's important to know about it. In any case, if you have problems with your key, you have to go back to the credentials page and regenerate the key. In order to change the key manually in your app, you have to edit plugins, ios.json or android.json file. Here in the android.json file, you can see your key. You just need to edit the API key line and replace it with your new key. There are lots of ways to work with Google Maps. You can visit the GitHub page of the Google Maps plugin to learn more at github.com. In this video, we created a taxi app using Google Maps plugin. Let's summarize the section. We started with taking a photo using the camera plugin. Then we learned to share content using the social sharing plugin and displaying a term of service using in-app browser. And finally, we created a taxi app using Google Maps plugin and geocode support. In the next section, we'll learn how to theme the app. Hello, welcome to a new section of Ionic, Theming the App. In this section, we'll cover tasks related to app theme customization that are viewing and debugging themes for a specific platform, customizing themes based on the platform. Let's start with the first video of the section, viewing and debugging themes for a specific platform. In this video, you'll learn how to modify a theme quickly using SASS variables. Then you'll run the app and inspect different platforms for UI consistency. Although Ionic has its own out-of-the-box default themes, you might want to even customize your app's look and feel further. There are several methods to do that. First, change style sheet within SASS file. Second, detecting platform-specific type, iOS, Android, Windows in JavaScript, and applying custom classes or AngularJS conditions. Either of the mentioned two methods should work, but it's highly recommended to apply customization in a SASS file before the app is built in order to achieve maximum rendering performance. One of the biggest challenges in developing an app is to ensure that the desired look and feel for each platform. Specifically, you want to write the code and theme once and have it just work. Another challenge is figuring out the workflow on a daily basis, from writing code and previewing it in the browser to deploying it to a device for testing purposes. You want to minimize a lot of unnecessary steps. It's certainly difficult if you have to rebuild the app and test it independently for each mobile platform. Ionic 2 CLI provides seamless integration to improve your workflow to ensure that you can catch all the issues for each platform ahead of time. You can quickly view the app on various platforms in the same browser window. This feature is powerful because now one can make a side-by-side comparison for each screen with a specific interaction. If you want to debug JavaScript code, you employ the same web developer tool that you have been using in the browser. This capability will save you a lot of time, instead of waiting to push the app to a physical device, which could take minutes if your app is getting larger. There's no need to test the theme on a physical device because Ionic can render iOS, Android and Windows Phone in the browser. We'll start with creating a new app using the tutorial template. In the template, type Ionic Start and the name of the project. You know the process by now. The installation and building will take time, so we'll just skip it. When that is done, we go to the project folder. In Ionic 1, you need to set up SAS dependencies because Ionic uses a number of external libraries for this. However, Ionic 2 has no such requirements because all the dependencies are added when you create the project. Now we need to open the app.variable.scss file in the app theme folder and replace the colors variable with these commands. The default color codes can be commented out as shown. Next, open app.html and add the clear attribute to the toolbar code block here. Then we need to edit the hello-ionic.html file in source, pages, hello-ionic folder and replace the contents with the given code. Okay, time for testing. Test run the app in the browser. Use this command, ionic serve -l. The -l, Lima, command means render the app for all three platforms. There are 3 platforms here, iPhone, Android and Windows. Select the platforms you want. We can test on all 3. Great. Ionic 2 has made it very easy to develop and test themes for different platforms. Your typical flow is to modify the theme variable in app.variables.scss first. You should not modify any CSS files directly. Also, Ionic 2 project now makes it safe so that you can't accidentally edit the wrong core theme files, because those core files are no longer in the app folder location. To update the default color, you just have to modify the color code in the app.variables.scss. You can even add more color names, such as clear white, and Ionic 2 will automatically take care of the rest. That means the clear keyword is available as an attribute to any Ionic element that takes a color name. Here's an example of clear. The Ionic CLI is a very useful tool for debugging your theme in different platforms. To get help on how to use the Ionic CLI, you can type Ionic-H in the console. This will list all the options available for you to choose from. Under the Serve option, you should familiarize yourself with some of the important features which are seen on the screen. You can get more color palettes by visiting Mateus Cruz Roca's cloned repository at github.com. In this video, we've successfully viewed and debugged themes for our platform. Great! In the next video, we'll customize themes based on the platform. Hi, welcome to a new video of this section, customizing themes based on the platform. Previously, we viewed and debugged themes for a particular platform. In this video, we'll cover 2 possible customizations using SAS and JavaScript. We'll look at customizing of themes for various platforms and understand how they work in detail. Each mobile platform vendor has its own design guideline. In this section, we'll go over an example of typical workflow to develop, view, debug and address the app theme differently for iOS, Android and Windows Phone. In traditional developments of using either the native language or other hybrid app solutions, you have to keep separate repositories for each platform in order to customize the theme. This could be very inefficient in the long run. Ionic 2 has many built-in features to support theme changes based on the detected platform. It makes it very convenient by separating SAS variables for each platform. This will eliminate a lot of unnecessary customizations. As a developer, you'd rather focus on the app experience than spend time managing the platform. This is how our app will look like. It shows an iOS, Android and Windows app with different title bar, color and text. There's no need to test themes on a physical device because Ionic can render all 3 platforms in the browser. First, you have to create a new app using the blank template using Ionic Start. When that's done, go to the project folder. Now we need to modify the app.module.ts file and replace the entire body with the code shown here. This example expands the use of Ionic Bootstrap, which will be discussed now. For that, open the home.ts file and modify the code here. You need to add an import here and add code in the homepage class. Then go to Source, Pages, Home, home.html file and change the template so it looks like this. The title and content is changed. This is the only template for the app, but its UI will look different depending on the detected platform. Then replace home.scss file with this style sheet. There's no need to change the global variables, thus you only modify the styles for one page. The purpose is to demonstrate the ability to customize for each platform. Are you ready to see your app? Let's test run the app in the browser using the Ionic serve-l command. There are 3 platforms here again. The themes look different with respect to the font size and style. Ionic automatically creates platform-specific parent classes and puts them at the body tag. The iOS will include the .ios class, the Android app will have the .md class, so for style sheet customization you can leverage those existing classes to change the look and feel of your app. Ionic 2 documentation has a list of all platform modes and configuration properties at ionicframework.com. First, let's take a look at the Ionic Bootstrap class from Ionic Angular. You declared this in the app.ts file. This statement basically instructs the app to bootstrap with the MyApp project. The third parameter is where you can inject your customized configuration properties. There's a list of all config properties at ionicframework.com. One main thing to point out here is icon mode. Icons are very different for each platform in Ionic 2. The entire Ion icons set is now separated by the platform name. There are 3 platforms according to Ionic 2's documentation page at the link opened here. You can even search for the icon name using the Search Ion Icons buttons. Note that you don't need to worry about which icon to pick for which platform. Even though in this example the code forces you to choose iOS icon for all 3 platforms, you could just use the icon name and let Ionic 2 decide which icon to use. For example, when you state the icon name as add, Ionic 2 will use md-add if the user is using Android. There are several ways to theme your app based on the platform. First, you could add variables to detect the current platform, as in the homepage class. This .platform equals platform is what Ionic 2 provides. If you open up the browser console while running the app, you can inspect the platform object. So let's go to the browser app and click on Inspect. You can see the platforms here. This platform object has a rich amount of information. This is similar to Ionic.platform in Ionic 1. However, it's been restructured significantly. By making the platform variables available to view, you can use it to hide or show a specific DOM using ngIf. It's recommended to use ngIf instead of ngShow because ngShow may show and hide the element right away, creating a flickering effect. This code in the template relating to those platform variables. Finally, you could change the theme platform classes directly. Consider the example. This means that whenever it's a material design mode, .md class, you'll override the classes with your own styles. This example shows an interesting CSS gradient, which works very nicely in mobile devices. Further, device information is available from the platform class. You can even detect iPad devices at Ionic Framework docs. So, we customized themes really well in this video. Let's have a quick and short recap of this section. In this section, we first viewed and debugged themes, and then customized themes depending on the platform. The next section will take us to publishing the app for different platforms. See you there. Hello, we're at the last section of the course, publishing the app for different platforms. In this section, we'll cover tasks related to publishing and future-proofing the app, such as adding versioning to future-proof the app, building and publishing an app for iOS, building and publishing an app for Android. Now we move on to the first video of this section that deals with adding versioning to future-proof the app. In this video we're going to create a new project, install app version plugin and then run our app and understand it. In the past it was very cumbersome to build and successfully publish an app. However, there is much documentation and many unofficial instructions on the internet today that can pretty much address any problem you may run into. In addition, Ionic also comes with its own CLI to assist in this process. This section will guide you through the app, building and publishing steps at a high level. The purpose of this section is to provide ideas on what to look for and some gotchas. Apple and Google are constantly updating their platforms and processes, so the steps may not look exactly the same over time. It's typical that you don't think about keeping track of the app version for a particular user. However, as the app grows in the number of users as well as releases, you'll soon face the problem of update issues and incompatibilities. For example, a user may run an old version of your app, but all your back-end APIs are now expecting new parameters from a newer app version. Therefore, you might want to think about a strategy to detect the app version locally in order to notify the users for an update requirement. This is also helpful if your back-end processes differently for a specific app version. The app you're going to build is very simple. It will detect the current version and store the information in a service. This is what our app will look like. This app example must run on a physical device or a simulator. Let's get started. First, create a new My App version app using the blank template. and go to the My App Version folder. To create the app type, Ionic Start and then the app name. Go to the folder by changing directory. Next, install the app version plugin. For that, here is the command. Now let's open our app in the code editor. We need to edit config.xml by changing the version number. This is the config.xml file. Note that your widget ID might be different from the one mentioned here. You only need to change the version number. In this case, it will be changed to 0.0.123 version. Then create the services folder inside the app folder using the make directory command. Then create myenv.ts in the services folder. So go to the code editor and I'll create my file here. This is the code required here. We are declaring myenv class, which we'll use later on. This is your only service for this app. In the real-world project, you'll need multiple services because some of them will have to communicate directly with your backend. So let's open and edit your app.modules.ts file. We add an import here regarding the service we've created. The main modification in this file is to inject the myenv provider for the entire app. Save the file. Next, you have to open and replace home.html with this code. You need to replace the title with your app name and modify the ion content. After that, open and replace home.ts with this code shown here. Finally, as always, edit the home.scss in the same folder. Time for some testing. Go to your terminal and run the app. If you want to run the app on your physical device, type the command Ionic run iOS. For Android, type the command Ionic run Android. It's showing that our project is not an Android project, so we have to add the Android platform to our project. Once that is done, run the app again. Here is our Android simulator. When you click on Get App Version, it will give you that. In a nutshell, the app version plugin does all the heavy lifting. It's not possible for an Ionic app to find out the current version in its code using JavaScript. You may think that using local storage or cookie is an alternative, but the users could also delete that storage manually. In order to have a permanent solution, the app version plugin should be used because it can read your config.xml file and get the version for you. It's the best practice to create a separate service for all environment variables. That's why you should have a service called myenv. Also, you should inject myenv as a provider at the app level, because you want to instantiate it only once, instead of doing it every time a new component is created. Observe this code. Since all the app version methods are based on promise, you should return the entire project as a promise. Let's take a look at the getAppVersion method in the myenv.ts file. Then, in your page files, such as home.ts, you should call the getAppVersion method as shown, and use the .then method to get the result. If you open the console to inspect the promise object, you'll see that it has your app version value and the .then method. You can see that here. For more information about the app version plugin, you may want to refer to the official app version documentation at github.com. In this video, we learned how to add versioning on our app. In the next video, we'll build and publish an app for iOS. Welcome to another video, building and publishing an app for iOS. Previously, we added versioning to future-proof our app. In this video, you'll walk through the steps to properly configure everything in Apple Developer Center, iTunes Connect and local Xcode project. Publishing on the App Store can be a frustrating process if you're not well prepared up front. You must register for Apple Developer Program in order to access developerapple.com and iTunesConnect.com, because those websites will require an approved account. In addition, the following instructions are specific versions of these components: Mac OS X El Capitan 10.11.2, Xcode 7.2, Ionic CLI 2.0, Cordova 5.4.1. How to do it? Ensure that you're in the app folder and build for the iOS platform. So, type in Ionic build iOS. It's going to take a few minutes. Go to the Platforms iOS folder to open the .xcode proj file in Xcode. This will open your Xcode environment. You can find the bundle identifier here. Make a copy of that. Let's visit the Apple Developer website. Make sure you have iOS selected in the top left. First, you need to create a certificate. So, navigate to Certificate. Click on the plus sign at the top. You'll select Development and Production. Since you already have Development selected, go to the Production part. select App Store and Ad Hoc. Click on Continue. Once you've completed the form, you can save the CSR file and import it to your Mac's Keychain Access. Go to Keychain Access, Certificate Assistant, then to Request a certificate from a certificate authority. Type in your information. Choose Save to Disk. Let's save to a folder named This. Now this is done. Again, go to the developer website again. Choose File Upload. Go to My Test App Certificate folder and upload the file you generated. Click Continue. Download that and put it in the same file again. It will be added to your Keychain Access. Now let's go to App Registration. So click on Identifiers, App IDs. Here you're going to click on the plus sign again and give it a name. And remember your bundle ID you copied earlier? It's supposed to go here. Let's scroll down. If your app needs push notifications or other app services, you need to check those services on the page. Click Continue, Register, and then Done. If you need to push the app to a specific device, you must register the device. Navigate to Devices, click on the plus sign, Register device or multiple devices. Give it a name and provide the device UDID. And save it in order to register the device. Finally, you need a provisioning profile if one doesn't exist yet. Usually Xcode will create one automatically. However, you could create your own by navigating to Provisioning Profiles. Click Add Distribution, App Store. Then click on Continue and select the test app you created earlier. Continue and select the certificate to be included in your profile page. Again, click Continue. Here it would say My Test Provisioning Profile. Download and save it in the Keychain Access. So now let's go to iTunes Connect at itunesconnect.apple.com and click on the My Apps button. You're going to select the plus icon to select a new app. It will show this dialog. Choose the platform as iOS, give it a name, choose your language, and bundle ID. You realise that the bundle ID is shown up here. Fill out the form and ensure that you select the right bundle identifier of your app. There are several additional steps to provide information about the app, such as screenshot, icon, and address. If you just want to test the app, you could provide some placeholder information initially and come back to edit later. That's it to prepare your developer and iTunes Connect account. OK, the app name is already in use. I'm going to change this name. Let's change it again. Good. It's done. You can go through the My Apps page here and start filling out different information, including the pricing. If it's a game, go to the Game Center and modify this information. You can use TestFlight. When you prepare for submissions, make sure you provide the screenshot. Click on the Properties, and you can find the properties different sizes here. Now, open Xcode and select iOS device as the archive target. Otherwise, the archive feature will not turn on. You'll need to archive your app before you can submit it to the App Store. Navigate to Product, Archive in the top menu as illustrated. You may want to accept the keychain question. After the archive process is completed, select Upload to App Store to finish the publishing process. This is just a test app, so I'm not going to upload it now. There is a selection of images, icons, a lot of paperwork you need to go through. Sometimes you'll see that you cannot view the app in archive. In that case, here's a little trick. You can go to a specific folder with your username, the curly sign, and Library Developer Xcode archive, and this is where the archive is being created. So if you have any problem archiving, go ahead to this folder and clean it up. To publish, select Submit for Beta App Review. You may want to go through other tabs such as Pricing and In-App Purchases to configure your own requirements. How it works. Obviously, this section does not cover every bit of detail in the publishing process. In general, you just need to ensure that your app is tested thoroughly, locally, on a physical device, either via USB or TestFlight, before submitting it to the App Store. There's more. TestFlight is a separate subject by itself. The benefit of TestFlight is that you don't need your app to be approved by Apple in order to install the app on a physical device for testing and development. You can find out more information about TestFlight at developer.apple.com. In this video, we've learned how to build our app and publish it. In the next video, we'll build and publish an app for Android. Hi, this is the last video of this section, building and publishing an app for Android. Previously, we looked at building an app for iOS. In this video, we'll build Android release.apk, create key store, and package APK using zip-align. Building and publishing an Android app is a little more straightforward than iOS because you just interface with the command line to build the .apk file and upload it to Google Play's developer console. The Ionic framework documentation also has a great instruction page for this, which can be found at this link. The requirement is to have your Google developer account ready. You need to log in to play.google.com/apps/publish. Your local environment should also have the right SDKs as well as KeyTool, Jar Signer, and zip-align command line for that specific version. Let's see how we can do this. So, go to the terminal, and then to your app folder, the app which you want to publish. Build for Android with this command. Cordova build, _release Android. This is the line of code. We can see the Android-release-unsigned.apk is stored here. Let's open our app in the code editor now. The Android-release-unsigned.apk will be in Platforms. You can access it by going in Platforms, Android, Build, Outputs, APK. You can see it's here. If this is the first time you created this app, you must have a key store file. This file is used to identify your app for publishing. If you lose it, you cannot update your app later on. To create a key store, type a command line and ensure that it's the same tool version of the SDK. So go to the command prompt and this line. This is the line of code to generate the key. Now enter a password. You'll then have to enter your first name and last name, organizational unit, organization, and detailed geographic location. So once you fill out all this information in the command line, make a copy of this file somewhere safe because you'll need it later. Now it's done. So I've created my release key.key store file. The next step is to use that file to sign your app so that it'll create a new .apk that Google Play allows users to install. For that, you'll have to write this line. You'll have to add the name of the key store and the name of the app APK. You can just copy the path of the APK we built, paste it in this line of command, and write alias name at the end. So this would be the line of code we need to run to sign the .apk file, which Google allows users to install. You can enter the password of the key you created. Oops, I just misspelt the key store name. I'll just correct it. Okay, this is the key store name. And this is the full path of the unsigned APK we created earlier. Now, press enter. You can see that the jar is signed here. Cool. Now you need to prepare for the final .apk before upload. You must package it using zip-align. This is the command to do that. You need to ensure that zip-align is in the path, or you have to specify the absolute path. I've specified the absolute path under library. This is the path. Then specify the options -v/4, and the APK file we built earlier, and the name of the file we need to upload. This app name could be anything you like. You can use the same name I used. Once done, press enter. You can now see that verification is done successfully. Next, we need to log into the Google Developer Console at play.google.com/app/publish. Here you need to click on Create Application. Say Hello World App. Fill out the content rating and other information as possible for your app using the left menu. You can add here Store Listing, content rating, pricing and distribution, in-app products, services and APIs. You can fill all of this as per your convenience. Enter a short description and full description as well. So, now we're ready to upload our .apk file. The first step is to do a beta. Just go to the APK tab and upload for your first APK to beta. You can browse files here. Here is the hello world.apk inside the projects folder. So, once you're done with beta testing, you can follow developer console instructions to push the app to production. Here is the Promote to Production button. Then save the app. If you run into any problems while publishing the app, it's helpful to look at the Why Can't I Publish link here, in the dashboard's top right corner. Google will guide you on specific steps that must be completed or fixed. You can then proceed to publish the app. This section does not cover other Android marketplaces such as the Amazon App Store, because each of them has different processes. However, the common idea is that you need to completely build the unsigned version of the .apk, sign it using an existing or new key store file, and finally zip a line to prepare it for upload. So that's all about this video. We've learned building and publishing an app for Android. Great! This also marks the end of this section. We started off this section with adding versioning to future-proof the app, and then we moved on to building and publishing an app for iOS and Android. Awesome! So guys, our journey comes to an end here. I hope you've had fun learning skills to develop cross-platform apps. All the best. Keep learning, keep coding.